All right, welcome. So today I think what we'll do is we'll work a little bit on. I want to add, as you can see here, I've made a sort of little gem type thing. So what I wanted to do is I want to add some sort of like resource to the game so that basically when you kill a monster, I want this to drop, and then you're gonna pick it up, and it's basically gonna be like, I don't know, some sort of either experience point or like some sort of resource that you can use in some way. I've not decided yet on exactly what it will do, but I know we want to have it. So yeah, I'm gonna just implement a way for monsters to drop items, and basically every monster is just gonna drop this. We'll start with that, and then I also want the player to be able to pick up the item, and then also keep track of how many you've picked up and show it somehow in the UI. So that, I think, will be the goal of today's stream. So yeah, I already created like animation and the entity type and stuff for this thing. So let's go to the game code now. I also found a bunch of stuff that I've written down here in the editor and stuff, but I'll not go through that right now. Okay, so another thing I wanted to do was also I wanna change the project. Like the last time we added a new monster, which is the Und Blomma, and that is a. Oh, we start all the way over here. Okay, let me start the editor instead, so we can start at the correct place, or a little place a little bit closer here. Not this one. Well, let's go. Yeah, this place. So nice that you can just open the map and go to where you want to go. Okay, these guys. So, as you can see, they spawn these projectiles. I also adjusted the height when they so it matches with the actual projectile being spawned. And so what I want to do now is basically I want to slow down the projectile a little bit. I also want to adjust the shield. You see right now it like blocks both of them. I want it so that when the shield is, when you're standing up, the shield is like basically up here, so it will block like high attacks, and when you duck it's gonna block low attacks. That's how I want it to be, and but I'm not gonna do that right now. But what I want to do is I want to slow down these projectiles because I think they're a little bit fast. So let's go over to this code here. So here's the code for spawning the projectile for this specific monster here. And let's go down. We have the thing somewhere. Here's the speed thing. Okay, so so we just have a constant projectile speed. So let's, I don't know, cut it in third maybe. Let's see what that does. Okay, I think that's way better because it's like you can properly see the projectile and you have like time to dodge it, you have time to block it if you want, you know. So I think that's way better. Also, I should note that I did sort of copy this entire monster from like Wonder Boy 3 or whatever it's called, like Wonder Boy. Well, what it's called. I had this game when I was little. Wonder Boy and No, wait. Wonder Boy the Dragon's Trap, it was called here, where you could basically be. It's basically the same kind of gameplay. Actually, you had a melee weapon, you had a shield that you can block like high and low attacks, and then you could also like transform into different like animals, like to have different like abilities and stuff. I'm not gonna have that in this game though, I don't think. But I thought it's a really cool game. It's sort of like a Metroidvania in itself, where you have these different areas. You can defeat bosses. You get upgrades throughout the game, which enables you to find more secrets and enables you to go to different places that you couldn't go before. So it is kind of like actually one of the first like Metroidvanias, actually. But and this game is sort of copying the style a little bit. And those flowers are actually almost like 1-to-1 of the original, and because the original also had like flower enemies that shoots projectiles like that, and they had like one version where they shoot high and one version when they shoot low. So but anyway, enough about it. I just wanted to mention that, which is one of the big inspirations for this game, actually. Okay, so now we've done that. Now I want to go to I want to make a new, like make new things here. So we want to, okay, I'll just show this again. Where is this end? Here is, whoops, no. Oh, there's no cancel button here. I should add a cancel button. I have to go in and delete it afterwards. Oh, and then we crash because there's a bug. Okay, it's not perfect, you know. But anyway, here's the gem that I want to add. So I want to add this as a type of entity, and I want to make the monsters drop it when they die. And I also want to have the player be able to pick it up, and some sort of inventory system to know that, well, to increase this type of resource that we have here. So what can we do to do that? Well, we could use like components and systems to do it. So what we could do, which is probably, well, it's the easiest thing that I can think of right now. Well, I could include it in, you know, the monster AI, but the thing is, since death is sort of a concept that is outside of the monster AI system, I probably want to have it as a component. So I should probably have, like, you know, if we have death, we should have well, one thing that you could just have a loot component or something like that, like drop on death component or something like this, like spawn on death component. I'm just gonna have, well, let's see, where is our death system here? Here is our death component. Here is death settings, which kind of has like some metadata around what should happen, because the death component is basically like, yeah, it gets added to a creature or entity that is supposed to die now on this frame, basically. So once it's added, it's basically marking that entity as now you should destroy it. And then we also have an optional timer, so that you can set, okay, we know that this thing is gonna die, but it's gonna take like 1 second or something, I don't know. But then it's like, okay, but we also have death settings, which is like added at the start to every entity, so that we know, so that it basically tells the death system how to handle the death of this specific thing, which includes like if we should destroy the entity entirely, like just removing it, if we have a death animation, if we have a sound. Well, I guess death animation and sound is always there, but and then we also have this like get death duration, which is derived from the animation, and or if it should destroy directly, we don't even play the animation, it just dies directly. So what I'm thinking is we could include in the death system, we could include like a drop on death or something component that does that. So I think instead of trying to figure out what would be the best thing, I'm just gonna do that right now. And if we're gonna change it later, we could just do it. So it's not that big of a deal. We could just have like drop on death component. Well, let's just create a thing for that. So drop on death. So drift. All right. Now, oh man, it's fucking. I need to enable my fan here. It's super hot in here, especially in this room, because there's very bad like ventilation, and my computer is also like heating things up, and the sun is like directly on the windows and stuff. So okay, but anyway, also yeah, I forgot to post this session. Hang on a second. I need to tell everyone that I'm live here. There we go. Oops. Okay, and then here. There we go. All right. Is there anything in here? I don't know. Announcements. Oh, that's only for that. Okay, whatever. Let's continue. So, what do we want to do here? So, yeah. So, I mean, I'm just gonna do whatever we have required right now, and then we can always change it later. So okay, let's do this. Let's create like sort of I'm gonna do this approach. I'm gonna create sort of like an API in here where actually we could make like an API like a okay, yeah, well, okay, I'll start it like this. So first we will have not public, we will have drop on death. So what do we drop on death? We want to drop some sort of entity, which is going to be some sort of like predetermined thing. So I wonder if we're just gonna do this type of thing. Like we have, no, not this one. We have this entity type here. And Yeah, maybe we'll just add it there. I mean, why not? So it's basically it's gonna be like this thing, except we only need the type because we already have the position, sort of. Well, position could be based, that's like based on the original entity that's died, and ID we don't really have. So I'm just gonna have like entity type, which is basically, well, it's just gonna be this entity type here. So where do we have this thing? Is it L? There. Alright, so that's the entity type. And that's I mean, I guess that's basically it. Spawn on death. We could also, it could be called spawn on death. Drop. I mean, drop is kind of like, okay, what? Well, let's have it like this for now, and we can always change it later. Because what I was thinking is, well, let's add drop on the, let's add the system. And man, there's a lot of things happening outside. Okay, so let's see. We want a view that is gonna be. Yeah, we need this. Yes. The view. So we want to have death component. And the body, so we can know where it is. Okay. Now we need the iterator. Oops. So we're gonna iterate through all the entities. And yeah, so we know that they have death. We know that they have rigid body. What we need to check now is basically, do we want to spawn the thing at the end of the sort of death animation, or do we want to just drop it immediately? I think we just begin with, we're just gonna drop it immediately, I think. So, so we know that now we need to spawn it. However, what I'm thinking is the death component. I think that will basically say, okay, if you have destroy at, then it's gonna keep the death component. So I wanna have, so that means that we go in here and we spawn. We don't want to spawn again for the same thing that's already died. So I'm gonna check here. I forgot how we did this. So here we just go through each with the death component. We check if we should destroy it. If we do, then we destroy it. So we don't really remove the death component right away. So we should have a bool here that says if we actually already spawned this thing. Is dropped, and we set it to false. So we'll also check if, well, we'll get the drop on death component. And if it's already dropped, we can continue. Otherwise, now we want to spawn the thing. And we do have a spawn system sort of for this. I'm just gonna double check here because I mean, we don't use the spawn system, I think, because this is like mostly for monsters and stuff. We could just create the thing directly. Yeah, I think this is, well, I guess technically we could incorporate items in here as well. Yeah, because what this is doing is basically, okay, let's check, like we have an update function here. And so you have this spawn component. And yeah, and we're going through the spawn components and we're spawning the entities, and then we're also playing some particle anime. Like, I mean, it's not really particle, like, you know, the technical term particle, but it's more like an animation, a sprite that gets played, you know. But we're going through each spawn component and we're spawning the entity. So it's basically like a delayed spawn. It's something that happens at a specific like phase in the update system. Like if we go here, like it happens here, so we know when it happens, so it doesn't do anything weird. However, I think this is just spawning like an item, I guess. But what you could do, you could use this thing to spawn the item. But it's sort of, right now it's sort of catered to monsters. So we need to basically check if this is a good way to do it. In that case, yeah, this one. Okay, let's just create the thing directly. So first we need to create. So let's just create. Let's have a function here. Spawn entity and drop on death entity type. Oops. Which is this thing? Let's actually do this. Let's do entity type equals this. Oops. Alright. And void. Okay. So what we'll do is we will create a new entity. Oh yeah, we need the registry as well. Alright, now we have a new entity. So we need to add a bunch of components to it. So what do we need? We need to add I mean, this kind of depends on what type of entity it is, I guess. So I guess I guess this would work though. This is kind of doing the same thing because it's looking at the entity type, and then it calls the correct function for each entity. Yeah, maybe we should just use this. What about the particles though? So this takes the animation of the newly created particle, or I mean entity that we just spawned, and then I'm just checking. We're setting the animation to whatever animation we say is gonna be here. So that's basically another entity that, so we don't really have this. I guess this could be a nullable. Yeah, let's just extend this to work with items as well, because it makes sense. Particle animation, so if we have it, so this is a nullable now. Wait, what am I doing here? No. Oh, wait, this is a union, okay. Yeah, I'm stupid. This should just be this one that we're using here. So actually, if we go back here, we will just do we will add okay, I'll check how this is used right now. Create particle animation for spawning. Create entity for spawning. So we could use this function, and we need to supply a entity thing which has all this. But well, I guess it's fine. End spawn reason. This doesn't make sense in this context though. So we put the reason in here. What are we using that? That's only for one of the things. Okay. So I'll put maybe nullable for that. Probably could have create entity for spawning options, and then we'll do this. Actually, the options could be there, and I will remove you. Yeah. You know what? The options could actually be part. Actually, we can do this. Whoops. We'll do that because that will instantiate it with the default. All right. The options. And if we have this, we're just gonna assume that it exists. Okay. So now this will be spawn component. Well, we have it here, C, spawn component, options. All right. There we go. Okay, so is that true? Wait. Okay. And we'll go back to spawn and we will add, well, first off we wanna add the new type here, so we'll add what's it called? Small gem. All right. So now we can add it here. Small gem. Now this is an item, so we don't really have that. Yeah, let's just add it. So this would be small gem. So I'll follow the same convention we have in monsters, which is not the best right now, but okay. So there's our item type. Here, and we need to import that, and so you will be item type small gem, and I'll just copy that. All right. Now we don't use this thing, but we basically want to have almost the same thing. So let's go to, well, here's init mode. So let's just copy this, and we'll go to item. Health, we don't have health. Position. Okay, now we basically do a lot of things the same here. So we add animation container instance. Yes, that should be the same. So that's basically the thing that has our animations, which we do need to add. So let's check this out. Where is the thing? Okay, let's just go here and we'll see what we pass in here. Ah, there we go. Animation container. So here we need to add. Let's just add it here. So this would be small gem. Oh, yeah, I need to look up the ID here, which is animations. Here's the ID for that. Oops. That was the wrong thing. There we go. All right, and then all right. So now we have that, so we can actually pass that in to here. Okay, we already do that. And this should be small gem. All right, there we go. And this should also be, wait, this texture is called items, I think. And we also need to add that textures items. Okay. I'm gonna update the system later to actually automatically load in all the required stuff, but right now this is how we do it. So let's see, max health. No. Also, this should be like init item. Should be this function here. All right. The rest of the stuff should be pretty much the same. No gravity is false. We want to have gravity. We don't do anything with this. Static is, I guess, false. Okay, so what do we want to do with a small gem? Well, we do want to be able to pick it up, but I don't have a thing for that yet. I'm just gonna do this for now, so we can see that it's gonna get spawned when monsters are killed. Okay, so what else are we doing in here? So now we have the animation container is good. We don't really have a spawn animation. I guess we could add a spawn animation to the gem. It's not gonna be, I mean, I'm just gonna add I'm just gonna have this. That's fine. So now we have a spawn animation. Okay. Then we set the animation to spawn. We add a monster AI component. We don't need to do that. We don't need to do anything with that. Damage on touch, no. Health, no. Death settings, that could actually be, we could actually have a death component, like when it gets destroyed, sort of, you could say. Let's do, I mean, we could have an animation for picking it up, you know. That's more what we have. It's more like pickup, but I'm using death as a thing, but I'm just gonna, you know, do that. That's fine. Okay, so we have that, and this is the sound, which is bad. Sound, let's see. What could we do? Maybe shield block. Select, I guess. I don't have a sound for that right now. So that's gonna be played whenever we do the death or the pickup thing. Yeah, draw layer, fine. Direction doesn't really matter, so I think we can just remove the direction. Physics system, yeah, we do want to add this. This is gonna be like items. And then create group, enable collisions. Yeah, so we do want to enable collisions, but this is more like physics resolution collision. So you're enabling collisions to happen. So collisions can still be detected between all these things, but here we enable so that it's actually physically stopped with collision. So basically, the player wants to be physically stopped by the ground, the monsters want to be physically stopped by the ground, and items do also want to be physically stopped by the ground. Okay. Cool. So we got that. Alright, and here we're adding the thing. We also need systems. Yes. There we go. We're adding this. Density, doesn't matter. Restitution, static false, solid true. Yes, because it's supposed to be stopped by the ground. The shape, yeah. So here we actually, the hitbox is actually interesting here. We should implement a function in all items that is like the hitbox thing. So get hitbox. Alright. And I guess Where's the item type? Yeah, so let's do that. Let's do get hitbox. What else is function? Get hitbox. So this will be switch on self, inline else. There we go. So now we're basically forcing all of the items to implement that. Actually, you know what? We don't actually need to do all that. We can just say this. Density. Oh, this one is just a F32, so we do need to grab that. There we go. Now, what are we doing here? So get the hitbox. So we're just gonna return from center. Why do I not get completion for that? But we do center size minimal. So center is 0. Size is gonna be, I think, like 4 or something. And then minimal is true. There we go. All right. So that's the hitbox. What else do we need here? All right, that should be fine. That should be it for now. We're gonna add more functionality to the items later, but this should be good for now to actually spawn the thing in, I think. So let's go now to, I think, spawn. Can go here and check, do we do everything here that we need? I think so. Okay, now let's go back to drop on death. So, do we have everything that we need to do there? Also, we set this to true so we don't spawn infinite amount of times. Alright. So, we don't use this now. What we do instead is well, if we go to, what is it, the building spawner. Yeah, we're calling create entity for spawning. So let's call that. We need utils. All right. Init with random ID, sure. Scene, we do need, it's gonna be L. And the entity is gonna be small gem, which does not have anything here. So it's actually just small gem, I think, there. Yeah. Position. So we need the rigid body from body, I guess. So once we have that, we can grab the position from here, like this. All right. Right, so we don't have any reason there. T. I guess we're not using T. Entity type. Oh, right. We can just supply that there instead. Okay, so we're not using T. There we go. Okay. Well, I guess maybe actually, you know what? We can just remove this component instead of have this bool. Instead of we have this bool here, we can actually just remove the thing. Although we can't remove it while iterating through it, I guess. So yeah, so what we'll do is we'll just create a DOD to remove. Okay, components to remove. Array list unmanaged, and we will say this is entities, and wait, aligned. Erased unmanaged build. Let's just init with some capacity here, so that we don't have to like do that, like reallocate a whole bunch of times. So in this case, we automatically... Actually, you know what? We don't really need to keep track of it because we're gonna remove everything. That's right. We don't actually need this crap. Okay, so what we'll do is... we will just do... Well, we actually we do need an allocator. Because we need to duplicate the thing. So down here we can say duplist is going to be view. Actually, we could create a... Okay, let's actually like handle entities. Yeah, I changed my mind because allocator because in here, because we don't really have access to like a list, so we have to like create our own list. Append assume capacity entity. Okay, and then down here we simply go through all of the items which are the entities, right? Why does it say unknown? Okay, whatever. So then we don't remove the entity. What we do is we remove the component that is called drop on death. No? On this entity. There we go. So, and then at the end, well, we need to deinitialize as well. So yeah, so because we're looking at more than 2 components, we don't simply have a list that we can jump through, but we are building the list, and we're iterating through each component with both of those things. Then we are also building up the list as we go, and at the end we want to loop through all the things and remove that component, because we don't want to remove it here. I'm not actually sure what happens if we do that while iterating, but I'm pretty sure there might be some issues with that. So we want to do it this way, right? So, and the next time we go here, we already handled the drop on death component. So basically you're gonna add the drop on death component at the start of initializing the new enemy or the new entity, like a monster, for example. So you say drop on death, spawn a small gem, for example. So we already know where it's gonna spawn. However, this drop on death waits for the death component for it to be able to be spawned. All right, and yeah, and then we just call this create entity for spawning, which is gonna spawn it the next like moment that it can, which will automatically spawn this entity type. All right, I think I feel that's pretty good. Are we missing anything? We have some syntax error here. Okay, so now we get must handle all possibilities here, which is what? This is spawn. So spawning Spawning a small gem. Right, this is when you... Right, we're turning the custom thing into our real thing, that's right. Otherwise, if we have something else... No, wait, we're... Here we're turning our custom entity into a realized type, that's right. And here we're grabbing out from the entity type container. So we're basically matching the string against our entity types. And, or yeah, the ID. And then we're grabbing our tag from that and we're matching on the tag. Okay. Let's see. And then we have now we have basically turned custom, so we shouldn't get custom here. So we turn custom into the real thing, which is here. Okay. Must handle all possibilities. So what is missing? Okay, let's check this one for example. So duration and the spawn set and options, no member duration ended. Alright, this is, we have to do this. Okay, I'm not sure what's happening here. What is the missing thing here? Small gem. Player visit, trans exit. What is missing? Klet måste stänga in världsbanan. Klet måste stänga in världsbanan. Berling, Irblås och blomma. Berling, Irblås och blomma. I don't think anything is missing here. What is it talking about? Tile map? Is tile map missing? How could tile map be missing? Did I accidentally remove tile map? How could that have happened? Okay, well, whatever. Alright. Okay. No field name on Bluma in item type. Oh. Of course. Okay, that's it. What we want to do now is I want to go to monster here, init monster, and we're just going to add this to every monster. We're going to add a drop death component. Oh, we need to add this to our list of components. Oh, I named it something else. Okay. Oops. All right, drop on death. Right, so now we're dropping small gem. Now every monster is dropping a small gem. All right, let's see. Yeah, so I guess we can just test this, I guess. Okay, it runs. We don't have any monster spawning yet here, so... Oh, come on. Okay, so the components should be up and running. No? Nothing's getting dropped. Oh, you know what? I know why. Because we're not calling our new system yet. So... Game update. Where should we call that? I think before the death system update we should call it. We also need to add it to our systems. Drop all death system. What is happening? Drop on that system. Update. There we go. Okay. Now let's see what's happening. Oh, now we get some more compilation errors. Alright, the view needs 2 arguments. And spawn entity wants... Oh yeah, so we also need the body. I mean, we basically don't really need this function. We can just call this directly. Yeah. Expected. Oh, this needs to be mutable. Oh man. So is it because I'm holding... Right. Okay, let's see if we get some spawn like... Oh. Oh, okay. So... Yeah. Let's see. Let's go to Vending Spawner. Yeah, so, well, one thing, the Berling Spawner is actually killed, or, well, it's destroyed here, and it actually, we don't want that to drop a gem. So I'm just gonna do this. I'm just gonna remove drop on death here. Oh, we're not using... Where is the animation contains in there? Okay. I need to import that. I need you RC and spawn reason, I guess. This is a system. Monster air component, draw air component, video body. Alright. Okay, so yeah, we'll remove this on the entity. There we go. Okay. Right, so now it won't spawn it immediately. However, something crashed. So let's try this again and see what is crashing. Also, I should probably remove that monster because it's not gonna be like a good intro monster to have. I only have it there because it looks a lot like... Okay, so something goes wrong, and when... Okay. Drop on death. Oh, hang on. Did I forget to... Oh, right. So we should only be considering things that actually have drop on death here. Yeah, okay. Makes sense. Now that could probably technically be embedded in the types, maybe. Like get a compiler error instead. Okay, there we go. There we go. We can see it being dropped there. It kind of goes through the ground though. Not sure why that's happening. Is it like too low so it go? No, it should stop, I think. Also, I think it looked a little bit weird with the center of the item. It looks like it's dropping. No, maybe it's fine. Yeah, but it doesn't definitely just goes through the entire thing. So we're adding it to the items group. And in here we're enabling items. Oh, maybe we should we have to create it. I see. There we go. Probably had a warning somewhere. Maybe we should enable so that like warnings and stuff show up as a thing. It really embeds itself in the ground there. So either I think I'll make it larger or also, is it shining? Oh, we're never setting the animation to idle, I guess. Yeah, because it's not part of the monster AI system, so it's spawned, but then once the spawn animation is done, we wanna set it to something else. I was thinking of maybe we can have like a queue animation thing, but maybe not. I mean, we could add a system. And in here we could check like, okay, is the spawn animation done? Then we go on to something else. However, oh yeah, so we do actually add a component here, I think, for items, or do we? Where do we actually do it? Add item, where do we use this? So that's just to get that. And here, what are we doing here? Nothing really. Should we add the item type as a component? Sure, why not? Okay, and we can loop through all the item types. Now we can grab the animation container. Wait. What do we need? We need this, I think. So that's the animation. So we'll just check if the animation is done. T and the animation animations. Okay, so we can't. We don't have the name. No, we have animation. Yeah. If animation dot animation dot name. If the name is spawn. If the name is spawn and we're done, then we set that to animations get idle, looping is true, all right. And we add this here. Okay, update. Now where do we add this? I think basically here, I think item system. At the same time as monster AI makes sense. Okay. Doesn't really matter that much, I don't think. We're just changing the current animation. Alright, so this should change the animation. So let's see if we are getting the idle animation now. Kinda hard to tell, I don't think so. Looks like nothing's happening. Let's also do this. Let's open up the anything here. Let's just add a gem there. Let's open up this and just add that. Move that onto there. Okay. So now when we start, we should get that directly. And here we can see it kind of goes into the ground here. So we need to change the size of it a little bit. I think the height is wrong. So the height, so let's do 4 width. So the width is probably correct. I think it's more like, well, the height is almost like double. Oops. All right, one more, I think. Or 2 maybe, it should be. Because it's divided by 2. And it should be a whole number. Okay, there we go. Now it's correctly done there. However, we can see that it does not play any sort of animation. It just has the same frame. So why is that happening? So we're going through all the item types. It should have an item type now. It should also have an animation instance, because without that, it's not showing at all. And we're checking if the name is spawn and if it's done. I guess if the spawn animation is like looping, it won't ever be done. So it shouldn't be. So here it is. Well, it's not looping though. Also, one thing that would be cool to add would be a small like impulse upwards. It's gonna be like negative something. This takes mass into account. Yeah, so let's do times mass. Well, I guess we can put it in here instead. There we go. Okay, so now it should have like a slight, it goes up a little bit first. So when things are dropped, they're gonna be, yeah. Lower it a little bit. There we go. Okay, cool. So what? So why is this not happening? We did add it to game update, I'm pretty sure. Yes. We're looking for item types, which we do add to the entity here. So that should exist. We're checking if the name of the animation is spawn and if the animation is done. Right. If looping is false, current frame is the last frame. And where we have gone past the time of the frame. Should all be true. Then we get the container, we set the thing to idle. Let's check if we actually get in here. It should happen pretty quickly. Like after 0.1 seconds. So it should already have happened here. Alright, so we do get in here. It does change the thing. I mean, the animation, we can see it here, idle. Yeah, we should see that. Did I just miss it or what? Am I just impatient? No, I'm pretty sure it doesn't play. Did I forget to, do I have to like start it? Is that the thing? Start. Maybe it's like stopped from the start. I'm not blinking. Oh, there we go. Okay, cool. Alright, let's go and check. Let's go and see how this looks like when you kill a bunch of monsters. There we go. Yeah. Loot. Okay. Yeah, I just wanna add a little bit of animation when you pick it up. So let's take this. And we'll make, wait, I'm not gonna make it explode or anything. I'm just gonna take I want to have some sort of oops. Or maybe actually this. You take like the inner part and the outer is just like weird dust that is gonna now crumble away. It's always fun to make animations, and when you don't really see the entire thing until you're basically running the animation. Okay, let's do one more frame. There we go. Right, now we can go to our editor and add this in. So let's change the death animation now. Yeah, that's gonna be the pickup animation. Okay. I want to linger on this first one a little bit. And then maybe have like a gradual speed up. Okay, let's try this. Okay, so let's see. There we go. Now let's. Well, we're not gonna see it right now. What we wanna do is pick up on pick up component. So it's basically, you know, the player is gonna be the one touching something, and we're gonna pick up whenever we touch something is gonna get picked up. Now what that will be is gonna probably be different depending on the thing. So I think what we'll do is we will create a sort of inventory for the player. So we could actually do it right here. We could just add inventory here. Alright, and I will just say, okay, you have gems, which is gonna be some sort of unsigned integer. Start at 0. I guess we could yeah, let's just add it there. Alright, and then what we want to do is we want to add pick up. Type, pickup type, and this is going to be a union enum, and we're going to basically have like gem, which is going to be pickup gem. And this is going to be like amount. Okay. We're gonna have a pickup system. And let's now, what we need to do. So I think because of this system is only going to affect the player basically. And so what we need to do is we want to check. We don't need to loop through all the items that checks do you collide with the player. What we want to do is we want to get all the intersections of the player and then check, okay, does this include any items? So we'll check, we'll first get the player, so this is gonna be like just a player here. Get player component, I think it's called. Alright, this is gonna be like basic view, player component, and we're all gonna have one, so we'll just grab the player like this. Alright, so now we have the player entity. Now we need the player body. Alright, so there we have that. Now we wanna check, we wanna get intersections of the player body. So we also need physics system. Okay. So, and then we defer free intersections. Alright, then we need allocator. Oops. Alright. Now we loop through all the intersections. Right, so let's grab the entity. It's going to be intersection entity, no, entry key. Section. There we go. So let's now check if it's an item or if it has pickup. So we're going to do reg try get, which is going to be pickup, which we need to add to our components here. All right. Wait, where is this? Here. Alright, so we'll try to get the pickup from entity. Okay, so if we have it, if we don't have it, we can just continue. So now this is set to our pickup thing. And what do we do now? So now we want to do, we want to destroy the thing. Which reminds me that we actually need to also add some stuff here. We need to add like death settings. Oh, we already have. Okay, cool. So we actually need to add the death component to pick up. So we want to add death destroy at is instant. to entity. That was the other way around. There we go. Alright, so we're adding the death component in the instance, which will in turn cause the death animation to play and all that, and it will destroy it afterwards. What we also need to do is we need to remove the pickup from that. So we actually want to have, just like we did with the other thing, we need to store all the pickups that we need to remove in this case, so we don't go in here again, so the player won't like pick it up again. I guess we could also check if there is a death component. So if we get the entity, if there's a pickup, if has death component, then we also continue. If we have a death component, we can continue as well. So after this point, we won't like get duplicate entries in here. All right, or runs of this code here for that thing. So anyway, what do we do? So we are checking for the pickups or intersecting with the player. We are adding the death component. We're also preventing death happening several times. What we do then is we wanna, so what do we want to do? We want to like trigger whatever's gonna happen with the pickup. So apply pickup for, well, we're gonna have pickup. I'm gonna also provide the entity. We need to provide probably registry would be good to have, and also the player entity, right? Sure, why not? Okay, apply pickup. The pickup is going to be pickup. The entity is going to be entity, and the player is also going to be entity. There we go. Right. So what do we do now? Well, I want to switch on the pickup type, and I guess we could technically just provide like have a semi sort of interface thing where each item has its own like apply pickup function. You could do it like that. You could also just have everything in here. I'm gonna lean towards adding it into here, because then this function won't like be super big. We actually just call this from here, and then we can divide up the sort of handlers between each item. Okay, so that should be good there. So actually what we want to do is we probably just want to say pickup, apply pickup. So actually we should probably do this instead and just forget about this. Add this over here, make this public, have self, and remove you, and there we go. And here we'll say, okay, what am I? Or actually, what is my pickup type? And this sounds like something else, so never mind. But the type, and then we apply the pickup. There should be fine. Okay, so now we should have like apply pickup functions over here, which takes the registry. So they always look the same now. And then the entity and the player. Alright, there we go. So T is not used. Well, let's forget about that then. I'm just gonna do this to get. Okay, so we don't have any other compilation errors. Okay, cool. Now, what's gonna happen when you pick up gems? Well, we need to get the inventory of the player, so let's get the player component. There we are. And then we say inventory gems plus equals. Oh yeah, we need self as well. And I'm just gonna do this. That's fine. Yeah. And it's gonna be amount. There we go. Entity is doesn't matter in this case. There we go. All right. So now we should actually have that. Let's add pickup system to our list of systems. And go to game update, and we will add this somewhere. Now what would make sense to add it? Probably I don't know, maybe after drop on death. Well, no, the pickup. Well, it's not gonna matter. It's not gonna like drop anything on death. Well, it might do. So it triggers death, so we should have it before other things, I guess. Let's just put it here. That's fine. Okay. So in theory now we should actually be able to pick stuff up. Well, actually we need to add a component also to the items. So let's go to our init item function. And should we just add it here directly, like pickup component, or should we just no? Let's just do it here. So we got the entity, and we'll say registry add pickup. Where is this? Game there. And pickup. Hello Daniel 8757. What's up? Alright, we'll add this. Init gem amount is gonna be 1, let's say. It's what is called V something. This program language, if that's what you're asking about, is called Zig. Like this. Oh, the text editor. It's called NeoVim. And it's a variation on, or it's like a fork of Vim, which is the self and a version of VI or Vi or whatever. Yeah. Don't understand how people use it. Yeah, so it's there's a bit of learning curve. However, there is a small trick if you just wanna try it. It's like when you get into, let's say you go into it here, And if you want to start typing something, you can either press I, and then you're in normal mode, and then you can press, or you can press A to start typing. So then you're almost in like a normal text editor mode here. Does it have extensions like VS Code? Well, yeah, it has plugins, they call it, and it's not, I wouldn't say it's like as easy to use as VS Code. If VS Code is just like, yeah, you just run it and it's very easy to install things and stuff. In NeoVim and Vim, you have to like basically create your own like script to install the plugins. I'm not sure, I don't know if there's actually a program that helps you do it, but it's basically very much you have to like write a script to install the plugins. I don't really see a use for using NeoVim though, that's just me. Well, the reason I'm using it is because I really like the way you can do the way you're editing text, and the way you can copy, paste, and search for text, and do all sorts of stuff. But and you can also very easily write your own plugins and extend the text editor. I assume most people use it because it's super minimalist aesthetic. I mean, it's not really. It's I don't use it because of how it looks. Maybe some do, but it's more like the functionality that you get out of it. But yeah, it's like it's very configurable. Let's say it like that. It's very configurable, and I'm not saying that it's impossible to configure VS Code the way you want it, but it's like if you wanna make a plugin in VS Code, you have to go through a lot of stuff to just add something to your, like add some functionality. Here you can very easily add stuff to it, which is what I'm doing sometimes. What even is Zig? What language is like C or C++? It is its own language, so it's a lot like C. It's manual memory management, so no automatic garbage collector, and it's like a modern take on C. Basically, it's a low-level programming language, which is well suited for things like games and high performance applications. So it's like Rust. Not well, I mean, in in those aspects it might be like Rust, you know, but yeah, it's a lot different as well. It doesn't have the type system that Rust has. It has it like another sort of type system. It does have like compile time things. It's kind of hard to explain, but you can basically execute code in compile time. I'm not well versed on enough on programming to comment about it though. Okay, well, yeah. I mean, there's a lot of languages floating around that is like kind of similar, you know, kind of like low-level C-like languages. And Odin, for example, is another one that is also probably a very, very good fit for game development as well. But I haven't tried it out. I wanted to try this language, make a project in that, because there's not a lot of resources on Zig right now. It's a pretty new language, and I like I like exploring new things, so it's a very, very well fit for me. I just have a basic understanding of high-level languages, like it. Did you press enter in the middle of a sentence? I mean, yeah, so basically most of the difference between low-level programming language and high-level is basically just garbage collection. That's mostly the difference. And if you compare it to languages like C, well, there's more of a difference, I guess, because C is like an old language that has a lot of quirkiness to it. You consider Zig a high-level language? Okay. So what would you consider a low-level language? Like why is Zig a high-level? Assembler? Okay, assembly. Sure. I mean, it depends on your definition, I guess. You can't go much lower than assembly unless you're directly working with machine code. So assembly is actually a high-level language if you compare it to machine code. Nah, I'm not here to argue with you. I just, yeah. I would say it depends on your definition. You know, there's some people say low-level languages are basically, you know, C and a lot of things that are like C, like that you can work with pointers directly, which you can in this language, for example. And to me, my definition of high-level language is that you can look at the code and understand it's like plain English. And in assembly, you can't understand it like it's plain English. Well, I don't fully agree with that, because you can't really read it to understand it like plain English. You have to know what it does. Like, and assembly, it all depends on what you know about the language. Like, you can read it and understand what it's doing. And if your definition of low-level language is just assembly, then what good is that definition? You know, you could, like, then the definition is not really useful to me. Or seeing it as, you know, whenever you can manipulate pointers, whenever you can, whenever you have like manual memory management. I meant most programming language, once you know one, you can mostly understand the rest. I mean, sure, there's a lot of concepts that are transferable between programming languages. And but there are differences that will, how do you say, there are a lot of differences that from what I call low-level programming languages and high-level programming languages. It's basically the garbage collection, where you, yeah, there's a distinct line there. Like, if you have a language with garbage collection or not garbage collection, because then you have to have manual memory management, you have to have pointers and stuff. So that's different. So if you've learned a high-level language, you can't necessarily go and just do stuff in a low-level language, because then you have to learn more stuff. I meant my definition of low-level and high-level is like a broader term. Like, assembly for me is low and other are high. but in the high in the higher level like in the high level languages there's even higher level languages like Python and lower like C. Okay, well I mean sure, but then again it's like how useful is it to say a low level programming language and then you already know you're talking about assembly. Like why not just say assembly then, and then you can say like low level programming language or like one step above assembler, and you can have high level or higher than that or something, because there's no real like scale to it, because you can't really say okay level 1 language or level 2 language or level 3. It doesn't really mean anything. I don't know if there's an actual like official definition to it. When I hear low level language, I understand it like people mean C and C++. Yeah, so it's all about communication. What do you think people mean when they say it? That's a good point. Like, so it just gets confusing if, well, if you know that that's what people are talking about or mean, then that's a useful thing to communicate. If you're using your own definition and people don't understand you when you're talking with them, then how that feels like just a confusing way of communicating to me. But yeah, I can understand what you mean though. But maybe you should find a different word for it or a different definition. I don't know. Because it's like if it's like common consensus that something is defined in a certain way, and you come up with your own definition, then that feels like, as I said, that feels like a weird communication error or something. I don't know. If you understand what I'm saying, what I'm coming from here. It's just to be able to communicate with people, basically. You don't use your own definition in general conversation. I go with the regular definition people use, but you know, when I'm with myself, I use my personal. Okay, sure. Once you're fluent in writing opcodes in bytecode, you're basically a Python wizard. Oh. Yeah, I guess. Welcome, by the way. Thank you for joining. What type of game I'm making? I'm making a Metroidvania. Let's see if we can run it here, and I'll show you. I am currently like adding items to the game that you can pick up. I have to load my session here. How far into development? Well, I'm trying to finish like the first sort of like a demo area. So I'm not really sure how much I'm gonna like, how big the game is gonna be, basically. So I don't really, but I started in November. Yeah, there we go. So there you can see, now I can pick up the item here. So this is the new thing that I added here, but it's basically gonna be, well, the FPS is just for me when I'm developing here. It's not gonna show in the real game. It's just to get an idea of if I need to optimize something or so. Okay, so basically it's a Metroidvania, and you can talk to these guys if you want. Here's sort of the combat. So it's like a melee combat here, and yeah, now these guys drop stuff here so that you can pick up. Yeah, so this is basically the gameplay here, and then you're gonna move around and find like upgrades and stuff where you can access new areas and stuff. So that's basically the game. Oh, you never played a Metroidvania? Have you played? So I guess, well, then you haven't played like Metroid, because that's like the original. Like Hollow Knight, so was a really popular Metroidvania, which I'm taking a lot of inspiration from, and also older games like Wonder Boy. Not the first one, but the ones that came after. Yeah, so basically it's 2D side-scroller, platformer. You gain upgrades and abilities that allow you to access new areas and do new things, like maybe jumping higher, have a double jump, maybe breaking blocks, stuff like that. I played Hollow Knight, yeah. That is a typical sort of Metroidvania game. And it's like one of the best ones, I would say. But yeah, okay, so we now have the gems. We don't really show the inventory right now though. But oops. I guess we can start here. So this is what we added right now. We had a little gem that drops. You can go touch it and you add it to your inventory. Okay, but I guess we could add a little counter for it. Yeah, the frames, so I can explain that a little bit. The frame is bad in this area because it's a larger area with more monsters. I forgot exactly. I did find out what the reason was earlier, but I like some time ago, but I don't remember. I think it's the number of entities. And I haven't really run a profile on it to actually get the reason for it, but I'm gonna guess it has something to do with the collision detection system, because all of these entities, they are checking for if you're close enough to the spawn area. So when you get close to a monster, it spawns basically, and before they are spawned, they're basically always checking, okay, is the player close enough? And then we're also checking if the player is... Oh yeah, I remember what it was now. So it's actually the tiles. I can enable a debug view here. So... Oh, the items are actually not despawning properly. Okay. Well, anyway, here you can see basically the tile map, or the map here in question, are consisting of a bunch of lines basically. And so when you have a big map like this and a bunch of different tiles, we basically have a very naive solution to this, because the thing is that all the tiles are like, they are always gonna be 16 by 16 blocks. So you could, instead of having how I have it now, where I basically spawn entities that are sort of solid blocks that block everything, what you could do is have a special handler for just this specific type of tile maps, where every block is either on or off. It's either solid or not solid, basically. And that's basically what I have, actually. And then you can get a very fast, sort of optimized check for it, but I haven't really implemented that, so that's why it's that. I think this is why it's so slow, is because there's a lot of these entities that we need to like check collision for. But it's not that slow that it's like horrible. I mean, it's still 300 FPS, so it's like there's no problem really. It's just that, okay, if we, let's say we double this map size, then we might get a problem. Yeah, so this one is around 300 because it's a larger map in this specific area. So if we go to the next one, then we're gonna get back to, well, this one is particularly small, so now we're at like 900. So I think the amount of monsters doesn't really matter. It's the tile map that takes the most of the FPS here. And here we have the same sort of problem where we have a larger map, and so we get a lot of FPS issues, or it's really not an issue though. Like 300 FPS is not an issue really. But anyway, but it is a sign that something is poorly optimized, which is the tile map. So if we get to the point, I'm not gonna optimize it if it's not a problem, you know. So I think it's fine for what it is right now. So because I don't want to spend time on something that is basically unnecessary. Okay. Yeah. So. Okay. So let's add some UI to this. So we do have like health UI. We could just make this into just a UI system. It doesn't really make sense to only have like health UI system and then add something else, I don't think. So let's actually just change this to the UI system, I guess. Oh, we already have like a UI. Oh, I think this is like a helper. What do we call it? Like HUD maybe? What did HUD stand for? I forgot. I can't wait to get to these higher level languages once I'm done learning. What are you learning? Heads up display, yeah. So maybe it's the wrong term, I don't know. I don't care. Maybe it's just for FPS, but FPS games. First person shooters. Or first-person games, but I'm gonna call it that because I have a name collision. Health UI. Here we go. Let's name this HUD. All right, and then go to our systems. We'll rename you to HUD system. You are gonna be HUD. There we go. All right. I used to be learning languages like Python and things like that when I stopped. Then I just stopped learning them and decided to restart learning programming in assembly because I like to know how code works under the hood. Yeah, I mean that's a perfectly good, valid reason to do it. I also done that, and I didn't really do a super deep dive, but I did learn assembly, and I actually implemented my own like programming language when using FASM, and I wrote my own linker as well, like and compiler and stuff. So I did turn not only the code into assembly, but then also the assembly into machine code. and a full executable. That was kind of fun. But then I'm like, okay, yeah, this was fun, but now I want to use like Zig. And yeah, I started doing that. I never really got far into the languages, so it's not like I lost a lot of time. I mean, I don't see it as a waste of time. You know, any program language that you're gonna go and learn is, I don't think it's a waste of time. I think it's good because you learn programming language concepts, and you learn how this program language does things, and you can always take things that you learn from one language and use it in the next. Well, assembly is a little bit different because assembly is basically, yeah, it's like if you wanna have, you can't really transfer a lot of stuff that other program languages has because they've built on top of assembly. So if you're gonna use it, you have to like build your own system in assembly to actually do the things that higher languages do. And that sounds like a pain to do. Max I could do those languages, create a simple mod for a game. Well, I mean, the more you learn, the more you know, the more you can do. So it's like you could take it from any developer and they will tell you that you can't really learn programming in a week. You know, it takes a lot of time to get to the point where you can feel confident in doing stuff yourself, you know. And it also I also noticed this when I started learning. I did feel a lot that it was hard to actually understand. It was easy for me to maybe think about, okay, I want to do this, but then to understand how you actually get there was the issue. So I had a lot of problems like, okay, how do I implement this? And then I basically got stuck because I didn't know how to do something. But then you learn a little bit here, you learn a little bit there, and you learn, like, you know, the basic building blocks, and after a time you actually, okay, now I know how to break this down into smaller problems, and then we solve those problems, and then we can get to the end result in like I just learned basics in those languages. Yeah, learning assembly was pretty bad in the basic, and now it's far better. Okay, I mean, that's also programming. You can program stuff in assembly. It's just that it's a lot more tedious and harder. Are those LMV variables names, or am I wrong? So okay, a bit of technical lingo here. These are identifiers. Now in Zig you can define a constant, which is this keyword here, constant v. So v is a constant. The identifier is v, which is another name for name of this variable, so that you can refer to it later in the code. And Zig has the nice thing that you can basically define a constant to point to any other thing, basically. So this is just a shortcut. It's an alias basically of this thing, which in turn is this thing here, which is a struct. So it's basically an alias to not have to write the full name out here every time. So basically, yes, it's a name of a, it's, well, you say variable. Sometimes you can use variable interchangeably between constants and actually mutable variables. A variable in math is something that changes value, but this is a constant, so it's not actually a variable, you know, in mathematical terms. But that's just being a bit of you know, pedantic about it. But it is basically, yes, usually people say variables even for constants, just because it's like a universal thing that you say about things that have a name that is bound to something else. But yeah, so the answer is yes. Constant variable, well, that's an oxymoron, you know, because a variable varies. That's why it's called a variable. So that's not like, if you want to be like technically correct, you're gonna say just a constant. It's a constant. It's not a variable, it's a constant. But in the real world, when people are communicating with programming, like other programmers and stuff, you can say variable, and it can mean a constant, it can mean anything. It depends on who you're talking with and, you know, everything else. So the point is, just because someone says variable doesn't mean it's not a constant. That's my whole point here. Just a little tidbit about the word variable in programming language. But anyway, so let's see if we can add this thing. But it's fun to talk about programming. I love talking about programming, and I've even thought about, like, if I get more people in here and stuff, we can do like, and if people are interested, we can do like some learning sessions and stuff, because I really love talking about it and teaching as well, even though I'm not a teacher, you know, but I love just discussing things about programming. Okay, so this is like the health stuff. We could probably put this in its own function. Draw health, just to make it a little bit more sectioned off. So we're passing the registry and player. Draw health. Going through the assembly book made me realize there isn't really that many instructions in assembly. I would say it depends on which CPU you're using, and it also, I mean, if you're talking about instructions in assembly, it also depends on which assembly language you're using, like which assembler, because different assemblers actually allow you to use the same sort of basic instruction to do the basic same operation, but in different, like the move for example. In machine code, move is like, you can have a lot of different variations on it, which is not the same instruction in, if you look at like the CPU manual for x86 64. That was what I was also studying. So there's a lot of instructions, but some assemblers make it easier for you and basically condenses move and uses the correct one for each thing that you want to do for it. But yeah, it's so to me, if you're talking about, like, if you want to use the actual instructions of the CPU, I mean, that's how you that depends on how you want to define different instructions. If you need to make a distinction between those, then I would count those, because then you need to know, okay, which one should I use, you know. But yeah, it all depends on how you define it. So I'm just saying that there's a lot of different things that the CPU will like do different things depending on the instruction. But if you're just talking about the basic operation, then yeah, it's not that. But I would say some instructions are really like, okay, it's like, okay, wow, when will I need to use this? And basically it's just, you know, when you use a higher level language, you will be happy of the fact that you don't have to understand, okay, this is where it's perfect to use this weird instruction, because it's gonna basically calculate that for you. But you can do weird things like, I don't know, bit swap, and I don't know, there's a whole bunch of weird stuff out there that is like, okay, this is so just so you can optimize some sort of mathematical operation. But yeah. Alright, so we have that. Let's see, I also want to draw gems. Let's just copy this and we'll see where we end up. So, draw gems. We don't need a health. We do need the player component though. And well, now we want to get the texture items. And the size is this. And the item is in 0, 1. Dealing with legacy code problems caused by how old assemblies like multi-queue always having Raxby implicit destination and some other things is big. I mean, yeah, and there's also things like bugs in specific CPUs that is also handled by the compiler. So the compiler knows a lot of stuff that you don't have to deal with if you're using, for example, C or something like that. So it's like yeah. It's not wrong to learn assembly, and I encourage it to just get a appreciation of how things work beneath the hood, but also like how much is actually done for you when you use a higher level programming language. And so yeah, I mean, yeah, you can get used to it. However, if you're gonna do something, like if you're gonna actually make a project in it, you know, that's when that, like, that's what I wouldn't recommend, unless you're extremely interested in assembly programming. And that's is why you want to do it. But if you just want to build a project, I would say, like, after you're done with your like assembler stuff, learn a higher language. You can use there's a tool called Compiler Explorer. I'm not sure if you don't know about it. It's a really nice tool to actually see how higher level programmers program languages gets compiled into assembly. So you can almost use that to learn what like other languages. And that was probably better to just read the documentation. I only learned assembly because I really like reverse engineering optimization, but I will definitely learn how. Okay, cool. But yeah, my point was that if you're gonna build like a big project or something, I'm not gonna recommend assembly for any reason. Well, I mean, as I said before, unless you're like super extremely interested in assembly and that's your goal. Your whole goal is to build a big project in assembly and see if it's possible. I mean, of course it's possible, but it's like it's gonna be a pain in the yeah. But you do get some sort of you do get like a very nice feeling of wow, I have like total control, I can do whatever. But then it's like, okay, do you really want to have it? Do you want that? I mean, it's not bad with control, but it's more like, do you really want to have no basically optimization, automatic optimization of the code, and you have to basically figure everything out yourself. Once I started coding in assembly, it made me feel like, I don't know, that high language kind of baby around you when you're coding. Yes, you can get that feeling, but then you can get another feeling, which is appreciation for the kind of, as I'm saying, like optimization and automatic code generation that you get from high level languages. And if you're using a low level language like C or SIG, then what's it called? The pros and cons. What the fuck is it called? Not payload. Well, yeah, the pros and cons of using versus not using is like it's worth the cons, you know. That's what I'm trying to say. I forgot what it's called. I really like coding assembly though. It's a really unique experience compared to other languages. Yes, it is. It's really, I mean, it's really nice. I actually really liked it until I got tired of it and then went back to higher level languages. It's just that's my personal experience. That's why I'm saying that it's like it feels really good because you have like total control and you can do anything and you can sort of make up your own language. And then it's like, okay, but when you want to do more advanced stuff and more like when you just want to make something, get things done, then it's another experience. Hopefully once I'm done I can get a pretty good base for learning higher language. Yeah, I mean that's yeah. I mean you do get an appreciation of what you get under the hood, and yeah. But I will say that it's not necessary, you know, to learn assembly to get into high level languages. But it's but I know I'm really like, you know, I have to know how it works, because I just have this I have this feeling that okay, but how does it actually work? Because then I can use that knowledge to maybe apply to something else. So I learn how it works under the hood, and I just don't learn just this thing that I'm seeing in like a tutorial or something. I have to, you know, I will be able to do other things as well. But I will say learning assembly doesn't actually sort of help you with that. It's just I would say it just helps you understand how it works under the hood. But I would say maybe for low languages where you have to deal with pointers and stuff, you get really nice appreciation for how pointers work, you know. But because you don't have to scale it by the size, and you don't have to, like when you want to look an item up in a struct, you also tend to like use the constructs of higher level languages, but you rebuild it in assembler for like, and even assemblers also use like these things like structs and stuff like that is not actually part of the assembly language, but it is sort of like a, I don't know, help thing that you get when using an assembler. So so I would say basically is to kill your curiosity for what's going on under the hood. And it's good because if that is the thing that bothers you, then you want to learn it, then that's good. It's good to learn things. You can even go and learn how the CPU works and the hardware behind it. I dabbled a little bit into that, but I have a limit as well. My passion is programming and not hardware. But it is good to know a little bit. Okay, so let's see. This is the player component. We want to draw, we don't want to loop. Basically, we want to, wait, what is this false here? Horizontal flip. Yeah. We want to check, well, this doesn't matter. And then we have the position. Yeah, okay. Wait, let's go back. Did I miss something here? No, it's just plus. Oh, it's a grid. I see. So this will be like plus 1. Okay, so let's do 1, 2. There we go. I mean, for me, I see most programmers start with something like Python and work their way down. So I was like, why not start with the hard stuff so I can get it down? Yeah. Let me know how it works out. I mean, it's impressive that you go that route, and it's also like, it's. I think I will say, like, when you go to higher level, you're gonna learn like different concepts. Also, that is the thing. Like, I started out with C++ when that was like a long time ago. I started out self-teaching myself C++ before, like when I was, what can I have been, like 11, 12 years old or something. But then yeah, so it went, you know how it went, because at that age and stuff. But so it didn't go very fast, but I did learn a lot of things, but it was super hard. But my point is, I learned what we call imperative programming. So that's like one paradigm of programming. And then I started, and then somewhere along the way I was like, hey, let's try out Haskell because it looks pretty cool and elegant. And I started to learn that, but then I quickly realized that it was super hard to take this information in, because I was so programmed into the imperative style that I basically had to rewire my brain, it felt like, to be able to learn functional programming. But then once I learned it, it was like having having two languages that I could switch between, basically, like programming in functional and then in imperative, because it's quite different. Nowadays, higher level programming language like C#, for example, has both paradigms built in. It's kind of interesting, because C# started out being super hardcore OOP, and then because everything needed to be in a class, but now you have a lot of like functional stuff in it, and you don't even have to have a class when you start a project in the latest versions. So I think the point is that if you go from one paradigm to another, you basically have to learn. You have to sort of relearn and learn how to do it. Learn programming in this new paradigm to be able to like think, okay, how can I solve problems in this new language, basically. Source. Alright, so that is the source. There's only one source. And this one doesn't exist. There we go. Okay, so we should see something on the screen. You're also still in high school. When I go into engineering, so I thought putting assembly on my college app would help me out. Okay. So into engineering, like what kind of engineering? Software engineering, or? Okay, now we can see here we got a little gem here. That is the UI. Maybe we can move it up a bit. Computer science. Mechatronics. Is that like robotics, or I don't know what that is. Like robot. Engineering. Robotics, but broader. Okay, cool. So right, they're a little bit not really aligned. Well, then I can understand going more low level, because you would need to go more low level. I mean, I guess there are like compilers that compile down to maybe Python or something, I don't know. But yeah, it's like if you want to have if you're supposed to do super performance stuff, then assembly is a good way to go, actually. I mean, it's possible. It's probably better to go with C or some other low level language like that, if you actually want to implement something for like a super performant embedded stuff. We were trying to learn coding when he was 9 with C#, but up until recently he was super procrastinator and never put in enough effort. So now I'm about to go into senior year of high school next month. I gain motivation. So yeah, I mean, you got a long way to go. I mean, you got a lot of time on your hands. Do it while before you have to spend time on other stuff. So for me, it was like I had a lot of fun programming, and was a extremely, like, I don't know if it's called like if you get like a dopamine hit, or I don't know, but once you get something working and it's like you did it yourself, that was like a huge impact. Okay, so let's try this. See where it ends up. Okay. I'm not gonna make this super fancy or anything. I'm just gonna do this, and then we need to print the amount. So we'll need this. I'm also gonna do text. So we do have draw text. But I think draw text is actually also grid position, right? Yes. Okay, so we can draw text. Oops. The position is going to be offset plus 1 format arguments gems options wait, what's this? There we go. Wait, what's happening here? What am I missing? Oh, that was the end of the thing. Okay. All the good parts, pretty good at coding, comprehension. I could probably finish assembly book by the time I get back into school. I mean, that would be awesome. The frame times in gaming, even the areas where you get like 800 FPS, it just has like 1% low of 500. I see. Yeah, I think the important part is it shouldn't go below like 60 or something. If it does that, then you got a huge issue to deal with. It makes sense that it would have a lot of FPS, since it shouldn't be. I got a pretty, I mean, I don't have like a super high-end computer, but I don't have a super bad computer either, so it makes sense that the FPS would be pretty high for this type of game. But I mean, if you implemented stuff non-optimized way, then you can still get bad FPS, you know. Depends on how much you're doing. But okay, you can see up here we we have a little X and 1, but it's not properly. Okay, as. I think it's because the texture is actually 32 by 32, or the sprite sort of the gem is 32 by 32. But we actually. So we could do this. We could use half the size. Because That's gonna make it into a 16 by 16 texture instead. Okay. And now if we place it over by 1 and down, it's gonna look a little bit better, I think. So the thing is, the original text, the sprite is like this, and now I think I've placed it in the middle, but then the size is like half, so it's like this, something like this. But it seems like it's not properly, maybe because the text needs to be, well, the text needs to be sort of centered, or does it need to be centered? Let's try this. Let's do initialize. Let's do like 1 and then 1/2. Let's try this. If the problem is with tiles, you can maybe make the pitch black tiles background instead of real tile. Make sure collision's fine so you can't clip into it. Yeah, sure. I mean, as I said before, I'm not gonna deal with it because right now it's not really an issue. If we want to have like double the size of that tile map that we had before, then it's maybe gonna be a problem. But I'm not gonna change it. I've already optimized it a little bit to the point where we get these lines. Before it was even worse because each tile actually spawned its own entity like this. So this entire line was like, I don't know, 100 tiles or something. Then it tanked FPS. But right now it's like, yeah, it doesn't really matter. Yeah, it's like I'm not gonna worry too much about optimization until like polishing stuff at the end, unless I like encounter something along the way that is like, okay, this is like unplayable and I have to test this, so then I'm gonna do optimization. But I'm probably not gonna do anything until then. But it's a good suggestion. Yeah, that's what I'm trying to do. I'm trying to align this a little bit. I'm just gonna wing it here. I'm just gonna, you know, do it like very unprofessional here and just try to match a little bit. Okay, there we go. Also, this is like a little bit offset, so I think I have to do. Well, let's do like 75 maybe. There seems to be a method to the madness here a little bit. 0.25. Yeah, now it's like almost perfectly aligned here. Maybe there doesn't need to be a space here. The space is quite large. We could do 2 text rows. One for the X and one for the not X. And then we increase this by, I don't know, 125. Probably needs more. Also, this is probably gonna change, so I'm not gonna also spend like a super much amount of time on this. I just want to make it look a little bit better, and then we're done. Because I think in the end we probably want to have maybe another type of UI, but I'm not sure actually. Okay, maybe 175. We'll see. But this is easy enough to just adjust it a little bit. There we go. Now we got an even space here. All right. I mean, we could center the text. Like it looks. This goes down. I'm okay. You know what? You know, this is the thing. Also, if you're bothered by this stuff while things are not like finalized, you're gonna spend a lot of time doing unnecessary things, and and not enough time actually progressing. So I'm just gonna leave it there, and we're gonna probably change it later. Okay, there we go. Okay, one thing that we actually can do, you see when we pick this up, is place a little animation there. And so one thing that I want to do, I want to actually, I think I want to try drawing items on top of players. Do those gems count as currency or something? I haven't decided what it's gonna be. I just know that I want to have something dropped, and that I want to, like, you know, collect it and show how much we have. But what they actually do is, like, it's undecided right now. But it's probably gonna be something like either sort of experience points or something that you can use to buy things, or yeah, we'll see what happens. OCD people get bothered, yeah, but the thing is they're not gonna see it until it's I mean, they're not gonna. Do you mean people that's gonna play the game later, or people that watch the stream? Let's see. But yeah, I mean, I get bothered by it, so that's why I fixed it. But I'm not gonna sit and perfect everything. That's what I meant. Now what the hell? What I was doing? Oh yeah. So if we look at, I think it's the initialize part. We have a bunch of stuff in the initialize part. We are loading the scene. No, not that. It's level. Yeah, we're loading the tile map. So what I want to do now is I want to add another draw layer. So the thing that we have like now is we have a bunch of draw layers. It's basically the tile maps have like X amount of layers. You can define how many layers each tile map's gonna have yourself. So that can vary. However, it also says that, okay, first you have a bunch of background layers, and then you have the character layer, and then you have the, or first you have the, wait, is the monster before or after? I forget, but you have the monster and the character layer, and then you have the foreground layers. And so what I want to add is also the item layer, which I want to have like at the front, like it's gonna be painted on top of the player, basically. You think coding a Metroidvania will be harder or easier than a roguelike? Like coding wise, I guess it depends on what type of let's say you have the same genre, but you replace the tag Metroidvania with roguelike. So I think roguelike would have because roguelikes are more based on repeatability, I would say. Like, well, usually now roguelikes have a bunch of unlocks. You can so each run will basically be a different run and stuff like that, and a lot of variation. So there's like, you have to put a lot of content into the game. But the same is kind of true for Metroidvanias, but depending on how large you want the game to be. So I think it's like, it sort of depends. And also, yeah. So the type of enemies that you want to have, the type of. I mean, I'm not that. I'm not actually a game developer. I mean, this is like sort of the first, well, serious project that I'm doing with game development. So I don't actually have a very well insight into that. But from what I know now, that's what I would say. It's like it all depends on yeah, how much you're gonna put in the game. And also I think like roguelikes are like, if you're gonna put in a bunch of unlocks, you're gonna put in a bunch of variation, then it's like it feels like that's gonna be a hell to try and balance as well. So that's like there's a lot of balancing going on that you have to do as well. And not that you don't have balance in like and other games, but since you have so much variations on how your character can become like powerful and stuff, then I see a lot of time going into that as well. Okay, yeah, and procedural maps. I mean, yeah, if you have a roguelike with procedural stuff as well. I mean, because then instead of drawing things manually, you have to procedurally make them as well. And if you want to have it interesting enough, that could be a lot of work, even though it's all generated. But and making it manually does also require a lot of work if you want to make it like unique and fun and stuff. But I don't know. It all depends. I would say. But I mean, coding. I mean, definitely coding a procedurally generated system is way more work than just drawing a time map that you have made in some program. So, I mean, basically the code for time maps in this game is basically just loading in the time map, generating a bunch of textures for the different layers, and then you draw each one. So that's the extent of coding for the time maps in here, basically. Which you probably want to have. I mean, the difference is basically that in a procedurally generated map, you would add more code on this system. So you would add code to generate the map. So it's definitely more code. As for more work, that depends on how large the game you want to make, how much time you want to spend on level design and stuff. But yeah. Okay, so where do we do it? I think, yeah, so we do have some sort of layer. Here's middle layer stuff. So the middle layer is basically between the background layers and the foreground layers of the tile map. And it can be more than one layer, so it depends on how many layers you want to have in between. But this one basically just takes gets you the middle layer where it starts, and then it's however many layers you actually wanted to add in there. So for now I think we only have two, like one for player, one for monsters. Yeah, so here's the number of layers that we have, 2. So we can just increase that by 1. And let's try and run this to see if it actually works or if it crashes now, because I'm not sure if we properly handle this. Okay, it does seem to work. Okay, that's good. And NPCs and monsters drawn on the same player, so they are behind the player. Yeah. So I want the items to be. I think I want the items to be in front of the player, so we can see the animation stuff more clearly. Now, so we have that. Where is this actually used? Oh, right, it's a variable that's set here. Okay. And here's the monster and player. Now let's add also the item, which is gonna be player +1. There we go. All right. Now we got that. Hello, Jonas. How's it going? I wish more shooting games had movement tech like in Titanfall or indie games. They always make the game more fun. Yeah, I'm with you. Or like the original Unreal Engine, or what I'm saying, Unreal Tournament 99 with the dodge jump. I think there was a mod as well where you can like run on walls and stuff. Or maybe there was another game. I don't remember. Source Engine games movement still. I actually never played Half-Life 2. To be honest. Was there special movement in that game? Oh. So what is different from that? What did you like from those movements? Systems. Right, let's see. Update spawn system. Here we go. So we actually want oh, this is like updated on the system itself. So we don't actually need to pass this in here. We can just use it ourselves. Monster draw layer, so we can just remove that. So this would depend then on what type of entity it is. So we don't put that there. Yeah, here we have it. So let's make some constants here. So let's do monster draw layer. And item draw layer. And let's take these and we'll replace draw layer with monster draw layer. And you will be item draw layer. In Source Engine, the movement you can do is very limited, but the thing with it is that it has such a high skill ceiling that if you get really good at it, it becomes a really nice movement system. Okay. Like, are you talking about things like bunny hopping? I'm not sure if bunny hopping actually existed in Source Engine. It was a thing in the old Half-Life game. Or things like that, or let's see, spawn system, spawn. Wait, level. No, game level 436. You don't need draw layer, that's right. Here we go. Okay, let's see if the... Wait, my controller is dead. Okay, I have to charge it. I'll just plug it in here. There we go. Bunny hopping and surfing is a whole community source engine. Like Surf and Bunny Hop servers have an active community on Counter-Strike for decades at this point because of how fleshed out it is. I did play the old Counter-Strike, like 1.6 when it had. Well, I did play before that as well, but I played sort of the old version, like the first version. Bunny hopping maps, or it wasn't it wasn't really bunny hopping maps. It was more like platforming maps that you could like jump. The goal was to just get to the end. That was really fun, actually. And then sometimes you had to, like, depending on the difficulty of the level, you had to like utilize different techniques. But I never really got that good at it. Okay, let's see. Now the item is... You can see it through... Or, I mean, in front of the player now. Okay, really cool. There we go. It's still behind sort of the foreground, but at least we can see it more now. Okay, now we can collect things that you can't do anything with, but... okay, so what is surfing? Okay, well, I mean, we did what I kind of set out to do this stream. So let's see, let's go to the tip 2 here. We do now have things like items. Is that a thing here? Yes. So we have gems, I guess. We have able to pick up items. Yeah, I mean, oh yeah, and we also have like drops, enemies able to drop items. There we go. Hard to explain without a video. I know for bunny hopping they had like in the, at least in the old like engine they had like you could not only increase the speed by bunny hopping, but you could also you could change the direction in the air, like your you could really like turn in the air very, like, what do you call it? A lot, very fast. Yeah. So basically jumping around an obstacle. A lot of people consider Source the perfect movement system. Okay. Cool. Yes, I mean, I haven't used it a lot, or played it a lot. I never played Half-Life 2. I did play Portal a little bit, and a tiny bit of Counter-Strike when the new versions. But after that, I I probably haven't played it. Got experience to understand? Okay. Maybe we'll fix the shield. Okay. So I want the shield to go up a bit. Okay, I'll remove this thing first. Let's see. Go to here. Remove this. And remove you. Okay, so the shield, if we look at the player, so the animation for the player is a bit weird. Well, we have like detached shields, and yeah, these are like old, that's not used anymore. Here's like version 3, I think, is what we have. Or version... okay, attack version 2 we have. So here's the base sort of thing. And then we have like the sword is a different. So it's basically put on top of the player. So we have like attack, sword, arm, and shield. So we have like basically 4 different animations going on for the player at the same time. I'm not good at bunny hopping and surfing at all, but I understand why people think that way. Okay. I understand. I wonder how many bugs in games are just devs who forgot debug stuff. I don't know. So this will, I want this to go up. Let's say, I don't know exactly how far, but it's gonna be like, let's say we go here, we go to, let's open okay, here we can have some. I will say though that bugs are, well, once you start a program, you get also appreciation of that bugs are basically a natural a natural byproduct of programming. So there's like no way of having a bug-free program basically, unless it's like a very small program. But and also the larger the program, the more amount of bugs. Okay, so basically I want this to be, so when you duck, where is that? When you duck, is it up here? I think it's down there, so it's like 4 pixels from the ground. And then the shield we want to have so 1, 2, 3, 4. So it starts here. 1, 2, 3, 4. Starts there. So we basically want to have it 4, and then how large is this? 13. So that's 17. So we basically want to have it here, I think. Except 13 size. So there. Okay, so 3 from the top. 1, 2, 3. Yeah, something like that. And then we need to adjust the arm. It looks a bit weird though. It looks too high up. Maybe... I don't know. Like from the arms perspective. Well, let's just do it like that for now. We'll see. Because I want to have, like, when you're standing up, you're gonna block high attacks. So, and when you're crouching, you want to block low attacks. That's why I want to, like, adjust this a little bit here. So how far up did we move it? 1, 2, 3, 4. So that was where it started first. Or that did no. This is the lower one. Okay, this is 7. So this is 12. So we moved it 5 pixels up. Okay. And then we could probably move this down, maybe. Let's keep it. Alright, let's see how that looks in the game. I hope I won't forget any debug stuff. We're gonna have extensive testing before... Okay, you can see how it looks a bit weird, but like... I don't know. And also, if I enable... Which button is that? Oh, wait. Oh, I don't think I have a button for that. Let's see, I want to see... this. So we can see where the shield is. Okay, here we can see the yellow part is the shield, and yeah. So when you're raised, I mean, it sort of looks almost like it makes a lot of sense right now, but it should be raised here up a little bit, because the whole point is, if we go over to let's just do this. We open the editor, we go directly over here. So here we have an enemy that throws projectiles. Oh, wait, a crash. Okay. Let's check this out. Unreachable code. Monster attack hitbox. Oh, I see. So the debug mode actually crashes it because we don't have a hitbox for this game, for this monster. So we want to go to the where is this debug? Yeah, debug and monster. Yeah, this one. So we get this. This one. Okay. I mean, we could make it so that it returns a nullable. I'm just gonna check here if it makes sense. Like here, that we actually abort this. I think that's fine. Okay, let's do this instead. Let's do nullable, and we will return null. Well, we don't actually need this. Okay. And then, well, here, if we don't get it, then we can, are we looping here? We can continue. And same thing here, if we don't get the hitbox, we can just return. Alright. Now let's go back and try this again. Takes a little while to compile. Or did it crash like immediately? Oh. Oh. What is the returns true if the player was hit or blocked the attack? Okay, so return false then. There we go. I should have a little text here, notification that says like compiling or running or something. Starting, maybe. Because sometimes it's like unclear, okay, is it actually compiling it or what is happening? I could go to here and check the logs. Okay, now it's running. So maybe I pressed the wrong key or something. There we go. Alright, let's see here now. Okay, there we go. Now we don't get... So you can see here. Well, now I killed that monster. Let's go out back in there. So the monster standing on top, we want to block. We're barely blocking that one, but we want to have it so that when you stand up, you're blocking the top one but not the bottom one. Okay, so let's fix the hitbox for that. We should have like shield hitbox here, and here we go. So here's the duck thing. So at first we have, okay, so the offset is 0 if we're not ducking, and then all there. Okay, so let's do, well, I mean, I guess we can do stand offset is gonna be Okay. Oh. You didn't actually see it. Okay, well I changed the offsets. So let's try it now. Okay, here you can see the offset. It looks maybe too high now, but we'll see. I mean, it probably still blocks this one perfectly there. But I want to, yeah, and now we get hit from the bottom one. So that's good. Does it make sense from like a graphical? Yeah, it does. So okay, that's a weird like spawn position. I think it gets like moved away from the when it's spawned. It might be spawning like in the ground or something. Okay. Let's half this, I guess. No? Oh, that's a vector. Yeah. Whoops. Yeah, that looks a little bit better. I also want to try this on the monsters that we originally had, like high low attack. So here is clear, that's a low attack, so we block that. Another low attack, another low attack. There we go. Okay, so it still works for, and if I do the other way around, so I do take damage there and I do take damage there, so it actually works perfectly for these guys as well. I didn't need to modify anything. Very cool. All right. So the shield has been adjusted. Very good. Shield polygon fake. Oh yeah. I was just looking if I fixed something that was written down here. No. Okay. Okay, so we did the shield thing. We did. We have a new item that we're dropping and stuff, like dropping things on. When you defeat monsters. Cool. What else can we do? So I added like this thing, but I don't know. For one, it doesn't really fit. I don't know. Well, it was. I thought that this was gonna be the game first, the gem, but it was like way too big for just a common pickup. Maybe it will be something else in the future. I don't know. Was there something missing on these guys? Oh yeah, we can fix the thing with the drop being weird. So here, let's see. This guy just drops it straight off there. I don't understand why they are different here. Let's look at this guy. Yeah, that works fine. So why would they be different? Respawning from the center of the body. And if we trust... Oops. If we trust this... Oh, here we can see why. That's a weird position. Oh, okay, so maybe... Do I have to set the origin here? No? What? Okay, I'm not sure why it's different. Let's check. I mean, it is static, but it should still... Oh, wait. It's the hitbox. Yeah, it's this one. This is wrong then. So this should probably be 0 and maybe, I don't know, 8. What's that? Do you have to click first and then... Okay. Have to like focus a lot on the window and then I can start, like, then it triggers keys. Alright, so I kill it. Now that looks good. Okay. Yeah, it looks a bit weird. It's a bit tall for, but at least... Oh, what's this? Do we have leaks? Oh, we're not cleaning up the list. Okay, yeah. Alright. Drop on death. And here, deinitialize. There we go. And there was another place where we had that. Was it the UI? No. spawn pickup. How about pickup? Here we also have, where is it? That's just the intersections, so that's fine, I guess. Okay, so that's already, yeah, we handled it differently here. Okay, yeah. Well, let's try it again, I guess, to see, just to see that we don't have an actually memory errors, or I mean memory leaks. Oh, we get a crash. Interesting. What? Integer overflow. What? Oh, where the initialize? Why did I do it down here? Wait, so we were actually were the initializing. Or did I put that? Wait. When did this? Okay. Let's just move on. So will we still get leaks? Yes. Or no, this is the old one. Yeah. No, no leaks. Okay, good. All right. Okay, we could actually implement our first quest, or I mean, yeah, first quest that is not like a debug quest, where you have to gather, I don't know, 100 gems or something. That's not gonna be a quest in the real game. Well, maybe it will be. Some things might be locked under some sort of resource. I have no idea, but it's not gonna be like the first quest you get. You have to kill 100. I don't know. We'll see what happens. So now I got 4. We could say like, oh, you have to get 5, so we can just easily. But what you could farm it as well, because you can just go back and forth. However, that's also sounds like some games. Once you clear a screen, and also we need to remove this enemy here because it's not supposed to be here. Yeah, here's actually a good way to farm it right now. It's just funny how you create a game to be able to farm easily some sort of resource. Okay, but anyway, so yeah, we could create that, but what would you get? Maybe another heart, a heal. You could pay to get healed now. Healing should probably be like free. You get some healing in the village or something. Yeah, so how would you do that? So you would go to quests. Now here's my quest list. Oh yeah, we already have this thing. Let's say gather gems. So yeah, so you first have your title or the label of the quest, then a description, and then we have like quest steps. So here's the descriptions are also a list. So each step has its own description. So the first step will be gather 5 gems, let's say. And then you can have steps that happen after that. So here we can have, for example, yeah, requirements. Wait, it should be a list, right? It's a list of steps. It's not a step. So this should be in here. I don't know what the LSP is doing. Okay, so the requirement is going to be something. The LSP sometimes doesn't really understand what's going on, so we can't get LSP easily here, but we can go to the step. And so here you can say we either have, no, we have a requirement, and then we have like things that happen on started or completed. So right now there's only two different types of requirements, whereas one is you have to speak with, you have to turn in a quest to someone, or you can wait. And there's no other like requirement types. So we have to add a requirement type here to be able to use. So let's say have gems or something. So the requirement is that you have to have some gems. Okay. And so we'll set the requirement to be have gems 5. Okay. And then we have, so now you can see down here how we have another quest where when it starts you hide a dialog option, and when you complete you can show another dialog option. So here we can say the same thing. So we want to hide Elder wants gems, and we want to show Elder wants gems 2. So that's like the next part of that chain. And well, these things are defined somewhere else. So these things are actually gonna be in the dialogues, like here. So Elder wants gems too. Now I realize the convention is actually different here, so we'll keep to this convention here. Doesn't really matter that much, but okay, so now we have that, and then we can go down to where we define these. So let's just copy these, and we'll say wants gems. So this is how you define dialog options now. So here's the option for that, which is gonna be like, do you want gems? I don't know. And then he's gonna say, I need 5 gems. Can you get it for me? And then you say okay, and I don't have time or something. I don't know. Here you can specify what happens when you take this option. So here you can specify, okay, well, I want to end the conversation. Here you can specify the same thing, but another action here, which is accept the quest. And then the quest is, what was it called? Like gather gems or something. We need to add it here as well. Gather gems. Yeah. So it's going to be gather gems. Okay. So then you accept the quest. Then when you're done with it, you're going to be over here, and we're going to say, I have your gems. Thank you very much. Here is, yeah, here's your reward. and then you say thank you, and you advance the quest, get the gems. Right. So when you advance the quest, you go to the next step. And if we look down here, we have another step here, which is like, yeah, the requirements to turn into elder, so we have to have the same thing here. So we add that requirement, and then we have, so you are, oh yeah, because this is like an NPC key, that's right, so that's like the old system. But let's see if this still works. So the requirement to have gems 5 on starter, we hide the original dialogue, we show the next dialogue. If, well, we want to show it if we actually now gather the 5 gems. But that's on, so that's when the step is completed, and the requirement to complete it is to have 5 gems. That's right. And so the next step, once you've talked with the elder, is basically you have now turned it into the elder. So that's already completed. And here is what's happening then. We hide the thing. And oh yeah, because you don't get a reward. That's right. So we hide the thing. However, we also want to do something else. So we let's see. So here's the actions that you can get. Right now it's only like show and hide dialogue, but we can add a new action that is called, I don't know, give gems, or get gems, generate gems, get gems. Okay, so that is now a new action that you can take. So get gems. I don't know if this was gonna be like how we're gonna have it, but it's basically just, wait, you turn in gems to get gems. No. You, well, once you turn it in, no, you will give gems. You will lose gems. That's right, you lose gems. So you lose 5 gems. Alright. And then, what else? Gain heart. And let's just, I guess you could gain more than 1 heart maybe. So, gain heart. So, you will, all these 3 was gonna happen because this is like a list of actions. So you're not gonna get 5 hearts, you're gonna get 1 heart. Okay. And now we need to implement these actions. So we look for where this is implemented, which is over here. Okay, resolve action. So lose gems. Gems to lose. So we need to get the player component. Now let's do a view. Maybe the player component should actually be like a singleton. But we'll get the player first, which is the first one there, and then we'll. Wait, do we even have C here? Okay, so we get the player. That's the entity. No, this is basically you. Yeah. Now we have the entity. Well, it doesn't understand that it's the entity. I don't know why. But. Okay, and then we get the player. No. There we go. So now we have the player component. Well, actually, we could do this as well. We could just say play component and then dot raw to get. So now we have the play component. Except it does the LSP doesn't understand it. But, and then we can go to inventory gems and we can do minus equal gems to loops. There we go. And this could, I mean, in the polished version, this could trigger some sort of animation where you're like, oh, you get like a negative, you lost the gems or something. I don't know. But let's do it like this for now. So this should just make you lose the gems. Now we can have also gain heart. Hearts to gain. So this is, now we need the player and we need health. Right, now we have the health and then we say health max health plus equals hearts to gain. And we probably want to restore all health as well. And again, this could have some sort of animation and stuff, but I don't have that right now. But this is, now we have the functionality at least for doing all this. And this is all part of the sort of quest and dialogue system that works kind of together to make this happen. So these actions are like, they are resolved depending on when you're, like which step in the quest you're, when it's completed and all these different things. So this should be enough to actually have this quest now, I think. Let's try. Also, yeah, we need to make sure that the elder actually has this quest. So we need to go into the NPCs, and so here's our NPC definitions. And so you will provide a bunch of starting dialogue, initially enabled dialogue options. So here is the starting dialogue. And so I think we'll replace waiting here with once gems. So this is what it starts with. And then here is basically we're saying these are all the possible sort of dialogue options that this person is gonna have. And yeah, we have to have it here for like technical reasons, but I'm just gonna, I don't remember what the exact reason was, but what is this now? Elder wants gem. Yeah, so now it's called gems 2. So you see, it is sort of fully compiler safe as well. Now let's see, switch must handle possibilities. Oh yeah, new step state. So let's see if I can remember how this works. Missing struct field kill clit. Oh yeah, we can remove that because we don't use it. Okay, so we have two errors here. Let's see. Cannot assign to constant. Basic raw. Okay, let's grab the pointer there instead. Now switch must handle opposite bit. So I don't remember what this was. New step state. Next step, we get the new state. So we take a quest step and return it into a state. Right. So I think it's like realizing the thing somehow. So what are we missing here though? So quest step. Alright, have gems. Oh yeah. Have gems. Now, and then we have step state. I'm not sure why we, well, I think because we need, right, so here's like t plus this. Okay, so we have to freeze it in time, basically, is why we need to have it. So have gems, let's just copy this. Alright. And now I suspect that we get another thing. Yeah, so we have to have, like, this is like requirement handler, I guess. But this part is, well, I guess we could. Gems to have. What we could do is we could just get the player inventory. And I say if player component inventory gems is more than or equal to gems to have, then the requirement is met, and we can advance the quest. All right, there we go. That wasn't too hard. Alright, let's see if it works. You should have the thing now. So, do you want gems? I need 5 gems. Can you get it for me? Okay. So now we have the quest here. You can see quest accepted, gather gems. And we can go into our quest log here in the pause menu to see, yeah, you need to gather 5 gems. Okay. So let's go and do that. Alright, we have 4. One more. There we go. And now you see quest progress, gather gems is done. So we can go back. And talk to this guy. And we can say, oh, this didn't get hidden. So that's a... Okay, I thought that was supposed to happen. But now we have this. I have your gems. Thank you very much. Here is your reward. Thank you. Quest completed, gather gems. And you can see I lost my gems and I did gain health. So it works. Woohoo! And supposedly I can do it again. Okay. But so that's a bug. Oops. There we go. And it's probably over here. No, quests. So we do say hide here on started, so I'm not sure why it goes back. Let's see, I'm gonna see here. Initially enabled. Wait, initially enabled. Wait, it's the other way around. Okay. I think. So this one, wait. Yeah, let's just do this. Get it. So the first list had only waiting, and the other list I wait. So there's no difference. Yeah, waiting and waiting too. I think this is correct. Yeah, starting dialogue is. Wait, starting dialogue. Oh yeah, starting dialogue. But then. And then initially enabled, and then dialogue options. Right. Initially enabled is the first list, and dialogue options is the second list. Okay, yeah. So dialogue options is like is this. This is like all the dialogue options that should be enabled for this NPC, and then you have the ones that are enabled from the start. Okay. So why is it not hidden? Does hide not work? Well, it did work. It did work here. Okay, I want to try again, because let's see if it's hidden at the start. So do you want gems? Need 5 gems. Okay. Quest accepted. Okay, now it's hidden. Oh wait, is it because it's not persisted? So when you go back and forth here, it's not persisting. Right, and so because the elder is now created again, it's not persisted when the elder is created again. Okay, so yeah, so now we're in the territory of like global, like yeah, persistent data. Well, not necessarily to a save file, but we need some persistent data that is global to the game. I think we have something for it. But the dialogues. So we do have like dialogue descriptions. That's these ones. But then we also have like state for the dialogue, which is stored in the thing. However, when we create the NPC, so let's go here, and we have somewhere we create the NPC. Now this just does that. Here's the NPC, okay. Initialization. And so somewhere we have the NPC AI component. Here we have dialogue component with starting dialogue and stuff. So we basically, this is like the dialogue state for the NPC. So we have starting dialogue, we have options. Right, so we could basically maybe limit the options we send in here. And this is just functionality for it, okay. So instead of sending in starting, like, well, it sends in every dialogue options. Hang on. If I talk to you, you say this, and then next time you say hi. So it actually did something here. Wait, what was the starting dialogue? Right, NPCs. Where is the elder here? Starting dialogue. Replace with text. Okay, so that's the thing. So it does. But then if you let's say we've talked to this guy, so now he says hi, but if you go back and forth, it's gonna do the whole introduction again. Yeah. So we need to do stuff. All right. And it's gonna be more than just dialogues that's gonna be stored later. It's like maybe the position changed, maybe yeah, it's not gonna be there anymore, or some stuff like that. Yeah, so I know I have like dialogue states somewhere. Let's see. Here's like dialogue states. What are we doing with this? Dialogue container. So we're looking through each initially enabled, and we're enabling them again. So this would also insinuate that they are not enabled. Yeah, so I think we need to extend here a little bit. So get option info. There was a long time I wasn't here, so I have to like re-familiarize myself with this. So option info is, I think, right, that's just, so option info is like it has the two things. It has the option, which is like the original sort of description of the dialogue option, which label text and responses and everything. And then you have state, which is like, well, right now it's only is shown, but it's sort of it's the dynamic state that can change. So basically everything in option is static, it will never change. Everything in state is dynamic, so it can change. And so we keep track of the, so we separate them because we only want to save the dynamic state in any kind of like save file or something like that. And then we map it somewhere to a key, which is here, auto array hash map unmanaged, dialog option key to the state. So that you can, if you have a state, you can go in and see, okay, do we already have state for this? And then depending on that, you can decide on what to do. So actually, when we go and initialize our NPC here, so instead of always initializing the enable the dialog options, we want to go through and we want to check something like if dialog container has state or something like that. So that means we have some state that we want to use instead. And then this is a key. So then we want to, so if we have state, then we don't really want to do anything because we already have the state. But if we don't have the state, we can do the initial thing where we show the option. Okay, so then, so that should be fine there. And then we also have, what is it here, the dialog options here that we send in. But now we want to send in something. No, but this should be fine. No, yeah, that should be fine because we already have the state. It's just that it's enabling the initial dialog options. And also the starting dialog option is different. Oh, that's different. We don't have state for this, I don't think. We're just setting it here. We don't have state for that. Oh man, that's... Because it's a little bit different. The starting dialog is a little bit different. We should probably have it in the same system. But the starting dialog is... Right, it is different. But we could probably have a key for that as well. Now these are like manually entered here. Okay. We could do this. So we can say that the starting dialog also has a key, which is a dialog option key. Okay. So now we can set the key on the starting dialog. Okay. And then we don't actually need these. Replace with is something that we don't really have for other stuff. We probably just want to have like that the starting dialog is just a dialog option key. And then these things are gonna be like, we're gonna define those. Yeah. So you're gonna define the thing elsewhere. This is just gonna be this. But it's a bit different as well. Oh yeah. So actually, we have this, okay? But then we also have another action for this, which is replace starting dialog with another key. There we go. Oh, we already have it. Okay, we already have changed starting dialog. Okay, I didn't say that. Okay. Great minds think alike, so to say. Okay, so let's see. Right. So now the starting dialog is not a thing. There's a dialog option key. There we go. Right. So now handle starting dialogue. So here we have like replace with. We don't really have replace with. We just, well, actually this is where we sort of trigger end of starting dialogue, because we don't really have that otherwise, I don't think. Yeah, it's gonna be like a choose option, and then we handle, where do we handle like the action? Handle choose response. Here we have handle action. Change starting dialogue, yeah. And so this is called from here, which is called from here. So this is like, this is only happening whenever you choose an option. However, we also have like after the starting dialogue is done, we want to handle the action that is happening with the starting, like after the starting dialogue. So actually, starting dialogue could be no, it's a key that goes into another dialogue. Okay. So now, or that points to a dialogue option. That's not really a dialogue option, it's like a starting dialogue, but okay. They are very similar. Where the hell am I? Wait, handle action. Handle starting dialogue. So here is like, okay, we're done with the starting dialogue, so now we want to handle whatever is happening when it's done. So we want to say handle action. Oh, we need the player component. Oh, we have the player. Okay. Target is target action. So the action is gonna be, is that just starting dialogue? Alright, so now we need the actual dialogue itself. Let's just call it option because that's the technical term that we're using right now. So we need a dialogue container that has all the states and stuff. And we want to get the option by ID. The ID is the starting dialogue. Except it's not a, wait, what the hell is this? Oh yeah, so it s dot starting dialogue. Okay, so there we got that. Then we handle the action. Actually, you know what, this state here, this can be that, but then this should be just a key. But then we have, then there's the other thing. This one. This one, the starting dialogue should be a option. There we go. And that's the key. Oh, right, now we need, now Okay. Never mind. I was thinking we should like initialize it with the actual option here instead, but then we need to maybe do some stuff that we can't. So, well, we probably can, but I'm not gonna unravel this whole thing right now. So anyway, so this will be the starting dialog option dot oh man, maybe this was a bad idea. You don't really have responses on the start. Well, I mean, you sort of do. Okay, so we're gonna do this then. It's gonna be a bit more to it than just this. It's actually gonna be a struct that has the option or the key, and then we also have on starting dialog end. We have an action. Where's that? Option dot action. So that's gonna be some sort of action that's gonna happen. Let's make it into like a list. Sure, why not? And the key is also const, or well, I guess it's constant. Okay, so now this is actually not the option. We don't need the option. Maybe. Text. Alright, you know what? Let's just go back. Let's go back here. Let's go back. Let's do Gamedev. I want to see, what did we have? We had text replaced with. Okay, that's the only thing we had. So let's just add text. Let's forget about the key. Wait, key was the one that we needed, though. So we do need key. Okay, we need this. We need the key. So that's the whole thing. We need the key. Actually, you know what? The state is gonna be different. So it's like, how do we know which starting dialogue the thing is gonna have? Like, you can't determine that by knowing which options are on or off. You have to have a separate state for that. We need like a separate state for that. Yeah. Okay. But I really wish that I could solve this somehow, but by having like the starting dialogue be the same as these other like dialogue options. I really want to have them the same. But then the NPC should store which dialogue option is the first, the starting one. So then we need like an NPC container, not only a dialogue container. Well, the dialogue container, I guess it could include that. It could include, so this is the states for the options. But then we can also have starting dialogue states. Which is gonna be from NPC key. I believe we have. Yeah. Or wait. No, that's just a string, I think. Well, fine. It's gonna be NPC key into a starting dialogue state. I think this is just gonna be a option key. Right. And we can, for example, now we can say get option by ID, but we can also say get starting dialogue by NPC key. And we get a starting dialogue from that. And the whole thing now is like this. Okay, starting dialogue. How can we represent those as the same? Like, we also want them to be part of the like how do we I really want to just put them in. Okay, you know what? Let's do this. Let's just put them in the actual same structure. So the option not only it will have label, text, responses. However, label and responses are not gonna matter in starting dialogue. But we can have on end. So this would be like what's gonna happen when this dialogue option is, or when you've gone through this dialogue, which is a list of actions. Okay, and let's make this nullable. Whoops. And we will set these to null from the start, so we don't have to deal with that. Now label is also sort of nullable. Could make these like safety things here. So this, and then we do responses there, and then we also have init starting dialogue where we only have text, and on end. So, there we go. Alright, then we have init. We can remove this now. Let's just do this for now. Right, so should show responses. And then we also have if. Right, should show responses is like we could get responses here then. Response. Oops. No. Where is this thing? Oh, it's like C dialog component option response. Okay, so if self is last page, and so actually if we have, let's do responses is equal to self option responses, right? And that might be null, so we do or else return null. If we don't have any, we return null. Then we check if self is last page, and oops, is text animation done, return responses. Otherwise return null. Actually, it is return responses. Well, I guess we could just return self option responses. Well, whatever. That's fine. So now we actually get the responses out like this, and we can do this. There. Responses. Okay. We have a whole bunch of different places to fix. Option for flavor. Yeah. So wait. What is happening here? Option labels. Right, so we're creating a list of labels. Maybe we should like make this into like you support making like an iterator instead. And then you have a support function that accepts a list, or this will be the iterator actually, so this will be like well
Okay, we're just gonna throw something in there that's gonna act as an iterator. Oops. Okay, and then when we loop through the labels, instead of doing this, we do while. You can even do. Okay, and then labels will be, this will be label iterator. Next. Alright. And then draw list is basically string slice iterator. Basically only gonna be used in here. I wonder if you can make an iterator like a generic iterator or something. Maybe not. Okay, so this will be an iterator here. We will have the value is this. Actually, you know what? This could even be a function. I mean, this could be iterator. Take the t. That is so. This is like so slice iterator. T is the type inside the slice. Return a type. This is what we return. So the value is going to be this t. Okay, and then we're going to have current to 0. A function called next, which returns return the sale slice iterator. And it returns a nullable t, and then yeah, we're just gonna check. So if current is less than value length. If it's more than or equal, yes, return null. Otherwise, current's going to be plus equals 1. Return self value. I wonder if this. No. Current. I guess we subtract 1 to get to negate this. Actually, we could defer that. And then return. How this work? Like, this will happen after, right? Okay, let's just do it safe here. So result is gonna be this. We return the result after we've done that. Okay. There we are. That's the iterator. Now this is going to be let's create the iterator here. undefined slices. Alright. No, slices. There we go. And there's gonna be labels. What? Alright. Right. Equals. Labels. There we go. Okay. And now we say self. No. Draw lists iterator. Registry, anchor points. Iterator and options. There we go. Right. Undeclared of labels. All right. Yeah, we have to iterate through it first, and then so we know the max length. Right. Okay, but then let's build in a reset function. Reset self slice iterator t and self current equals 0. Okay. So now we can loop through it, and we can also reset it later. Where is that? Here. So here we want to do while iterator next. Wait, how do we get like auto completion here? Does it know which type it is depending on the type you send in? Okay, well that's that's something that I did not expect this LSP to do. You can see here label iterator, we say any type, however somehow it's able to determine the type because we're using it at one place with slice iterator as the thing. Okay, cool. So let's grab the label out, and now we can do this part. Okay, and then when we're done, we will reset the iterator. All right, and so we can use it again down here. Right, and we can also do length as well. Okay, so we need to iterate it through it 3 times. Well, let's actually do this then. Iterate through once here, where we get the max length and the number of labels. So there we go. Now we have that. We can use that here. Okay. So now we have a way of sending in an iterator instead. So now when we go here and use draw list, we don't have to make a new list of labels. We can make an iterator instead. So this would be, let's make a option label iterator. Options is gonna be, well actually no, we don't need this. Wait, we do need it. Well, you could also provide a function, I guess, that maps the like, what if you do this, like map iterator, and you take, let's see, so you take an iterator, or you wrap an iterator, let's say, you give this a function which takes a value t, so let's say this has to be known then, so you have to take some value and you map it to another value. I'm using t and u here. And you take a function that can map t's to u's. And then you also, so now we get a type back. So we will take the iterator. It's gonna be some sort of iterator that, wait, can you, no, you can't have any type here. Well, you could, okay, this gets a bit ridiculous here. You could have like a v table if you want. Like you could have like generic iterator, which iterates types of t, and it has a v table. Which has a, well, actually it has pointers to next, which takes nothing and returns a nullable t. Okay. And I have a function next here. Which does that. Wait, we also need self, so we need this. Keep the state. Okay, this is how the allocators work. If you look up the allocator, you have a pointer and a v table, which is, here is a pointer to a const. I guess we can do the same thing. But then, and then you have a struct v table, which has these function pointers, and they are, the first is always NOPIC, so that's like the pointer to itself, so that you can keep, and that's like can be anything. So then it's up to the function itself, the implementation function, to actually turn this pointer into the type that you want it to be. But then it's basically the interface parameters here, And then the actual alloc function, where is that? Here it calls, well, okay, this didn't call it here, but here we have raw alloc. So this actually calls vtable alloc and then with the pointer here. So it basically does the same thing as we're doing. I just want to try this out. I'm probably not gonna have this thing, but we'll see. So you can't do, wait, no, you can't do this. There we go. So there's the vtable there. Probably want to have this outside then. Maybe. Okay. Except this can't. This isn't supposed to be generic though. Well, it is. How can you make it generic for all types? Or do we need to do that? I'm not sure. So yeah, maybe we do need this inside here. Okay. We can also have like resets. So you can implement whatever functions we need here. Resets. There we go. But that doesn't return anything. Alright, so now the slice iterator can be actually passed as a, I'm gonna call it G-slice iterator, and this will be a generic iterator with type T, and well, actually we'll do this slice iterator is this. Right. And then no, that's a type. Yeah, we get a type out. The T, yeah, so this can be a function. So we have function on some sort of slice. Okay, and then this could be like type of, but let's do a comp time t instead, so it's easier to implement here. So this is a slice of constant t's. Well, it doesn't need to be constant, I guess. And then what slice iterator slices slice. Yeah, slice iterator. Yeah. And then you have generic iterator of t's, right? And then you say pointer is going to be a slice iterator of t's dot init slice. I guess they should be const because they are const. There we go. And then vtable is going to be slice iterator t, I guess. Well, actually, it's gonna be v. It's gonna be next. That right? Oh, and this returns. This actually returns. Well, this returns a generic iterator t. All right. And so now we have like a type, which is a generic iterator that can represent any type of iterator over the type t. Let's store this in iterator here. Let's just move this thing. Yeah, so this one doesn't work, but let's just forget that for now. Comp time. Alright. I guess as they said const, I think you have to add const maybe. Okay. So now let's see. Let's go to lib. Let's actually add this iterators. Alright. So now here we have slice iterator, but we can say now we can add, we can do this. Actually, let's do this. Let's take t, let's remove t, let's call slice any type so it's easier to use. But t now is going to be type of slice and then the element of that. So we need standard here. Okay. So now, so that's that, and then that's also what t will be here. So this will be the element of type of slice. All right. So now we have a generic iterator from that we send in here. So that works. The reset? No. Okay, yeah. So here we have the wrong thing on reset. Oh, we even get like LSP stuff here. So that should be void. We're not returning. We're calling reset on self-voider. Oh yeah, we missed something. We missed one thing. Right, the v table doesn't work here. So well, one thing that's the problem here is these functions are not actually v-table functions. They are functions that work directly with the slice iterator. We have to make them like v-table functions. Now another thing is that this v-table here, how do you define it? I will just do like a slice iterator v-table is a v-table. Actually, wait. No, this should be a function time. It's a generic iterator t.v-table. How do you define this type? This like a type of this struct here. Well, I guess we can try it. No, wait. Let's check. What is it? Standard heap. Allocator, some sort of allocator here. Let's just check this, for example. Right, so here we just define the functions. Here's the v-table where we're doing this. Okay, yeah. Okay, so let's just do, let's make a iterators slice. Right, so basically we want to do this, except we can remove that. Actually no. Yeah, but now we want to return a generic iterator T. Okay. Except it's L. All right. Now this is the slice iterator. All right. But the thing is here, this is gonna be like generic. No, this is gonna be pointer to any opaque. That's the thing. It's gonna be a pointer to any opaque. And we wanna get, so let's call this pointer. And we're gonna get self is a slice iterator. And we need to do a pointer cost and a line cost, I think, on the pointer to get it. There we go. All right. So now we have the versions of next and reset that actually works with. Let's remove the init function. That works with generic iterator. Right. So let's call this. Well, let's just call it iterator. Iterator. It should be the same. Okay. But what do we return? We return a generic iterator with a v table that is iterator, right? The pointer is gonna be a new iterator with the value coming in here. Oh yeah, and now we do this again. So this is any type. This is element of type of slice, and T is element slice of type of slice. There we go. That's the iterator struct. We return generic iterator with vtable being the struct here. The value is slice. There we go. I'm not sure why it complains here. This should be visible. Let's just do this. Okay. There we go. Now let's go back here. We can remove this. Let's just remove all this. And we can remove this as well, since we have one now. I guess we could do slice iterator watch size. Could do this. So now if we go back here, we say this instead. Well, this is the type. And then no, wait, I did it wrong. Let's do it like this, yeah, because it's not returning a type, so it should be like lowercase. There we go. All right. Yeah. So like this, yeah. So now we got the iterator there. Okay, now this is like a generic iterator. but it does have the slice thing underneath. And well, there's no more errors in here. Cool. Okay, so that was a bit of a tangent, but it does work now. But the thing is now, we can actually take a generic iterator instead. Iterator generic. So now we can take it, we can make this sort of type safe here. I want an iterator that works on strings. So yeah. Oh, but now this one. Well, actually, let's see. No, this needs to be a pointer. Yeah. Oh, or a mutable iterator. There we go. So now we got, you know, we have full understanding of what we're working with, even though the LSP doesn't really sometimes work for things, but it does work. Cool. And the whole point of that, well, now we have a way of iterating through slices, but we also want to have, let's see if we can make a map iterator. So the idea here is that we provide a function that maps from one value to another that is getting applied after you iterate something. So it's let's see, a function map iterator. So the input will be an iterator, I think. Yeah, iterator. I guess it could be like any type. Or do we have to say which type it's gonna be? Let's just do this for now. We can fix it later. So let's put in a iterator, and then we also want to have a function mapper, which is a function that takes t and returns u. And so let's return u. I'm not sure if you can say any type in the result and have that like inferred. I'm not sure about that, but let's do it like this for now. Now this will return a generic iterator of u instead. Okay. And so let's go to our slice thing and we'll copy this. And our iterator implementation will have the inner iterator there. There's a t. We don't care about current. Reset. We will do self it reset. So basically just a wrapper around here. Next will be t. So this is the value. So we'll just call next on iterator. If we don't get anything, we can return null. So now we have our t. So now we just return the mapper function around t to get the value. Now here we just say store the iterator like this. All right. So it's more like maybe, I don't know if it's like a functional approach to this. Where you put in a function that you want to map around an iterator. Okay. And hopefully this works. Let's see. iterator. Alright, now we have that. And now what we want to do with that, we want to go, where was it? Here? Right. So the original programming thing we had here was that we have a bunch of options which are of one type, dialog option info. They have labels in them, and we have a slice of those. And then we want to call this function draw list, but this needs a list of strings which we don't have. So we have to like make a list of strings by allocating that on the thing. But instead of doing that, now we can actually make an iterator, because now we have draw list iterator, and the labels are going to be some sort of iterator that we put in here. And so instead of doing this, I will still need to free the options, I guess. But now we can say the iterator is going to be map iterator. Well, let's start with the slice iterator, and the slice is options. Right. So now we have an iterator that goes through the options here. Does it know that? I don't know. Right. So this is that. Now we can also wrap this in a map iterator. Oops. And the map, so from this is going to be from one of these, dialog option info, which we don't have. So let's just do meta ln type of options. Can we do this? Yes. And then the target, or the result, is going to be the string, and then the iterator is going to be the thing we put in here, and then the mapper function, we have to actually, you could sort of create a lambda here. It's not really, it doesn't have capturing, like what is it called, it doesn't capture the surrounding like scope, but it does. You can sort of define a function on the fly, although it's not really that nice, because you have to define a struct first, and then you have a function, which is the function you want to have. So this, and you can call it whatever you want, but this function is going to be like the mapper function. And so the mapper function takes this element here, let's just call this T. Right, so it takes an option T and returns the thing there. All right, now we just return. Oh yeah, we don't get completion on this, but we have to. Wait, no, that's not one. Here, this one. The return. So it's like dot option dot label. And also this returns null. It's a nullable. So I guess if it's null, then we return an empty string. Option.option.label. Okay, we don't get it. We don't get completion in because this type is wrong. Let's get basically with dialog component. No option. No, it's what the hell is it? C. there we go, there it is. Okay, so now this is the info thing. There we go. Now we get full stuff here. Okay, and we don't really need this. We can just do this. Alright. There we go. So there's our iterator. We're slicing through the options and we're mapping. So we avoid having to allocate a new thing here and populating it where the thing is by doing this. And it's like I when I did this, I realized that okay, maybe this is not the Ziggy way, but Zig does allow you to do some fancy things with the comp time, and it does have this pattern itself with the allocator, and it does use iterators. The only thing that's kind of maybe different is that we use a mapper. But it's like, well, the problem is that this function accepts an iterator. Maybe that's the problem in itself, I don't know. But it does accept an iterator, which I think this is pretty good. You could use this system for all kinds of things. I think. But yeah, so now we don't do this. So we don't, but the main point is that we avoid allocating here. And we can just iterate through the original slice and grab out the label from there just by passing an iterator. We don't really need to have a separate function that only works for option keys, or I mean a dialog option info. We can pass in whatever kind of iterator we want here, and it will work anything. So I feel like that's actually a cool way of doing it. And it wasn't that hard actually. It was pretty easy actually. Well, I guess we don't really know if it works yet, but so what's going on? Oh yeah. So you have to type .mapper there to actually say that yeah, this is the function. So this is a sort of an example of how you can sort of define a function on the fly, except it's not really a lambda, as I said, or an anonymous function, because it's not really like a value that exists in the runtime. It's more like this is a function that, but you sort of define it in this sort of inner scope, although it doesn't, you cannot actually say, let's say we want to use the allocator, you can't actually use the allocator from here, even though the LSP kind of says that you can. But let's just try, if you try and do this, you're gonna get a compiler error in here. I'm pretty sure. I'm pretty sure you should get a compiler error in here. But anyway, let's do that, because I'm pretty sure it doesn't capture the surrounding scope. Okay. Anyway, unless there is an allocator in here, then maybe it captured that one. Maybe, or maybe not. No. Okay. Okay, I don't know, but yeah, that works. So yeah, great. So let's continue trying to fix it here. So expected type. Okay, yeah, we need to pass it as a mutable there, and we need to also make it into a mutable. Right, expected starting dialog, found dialog subject key. Yes. So that was a tangent, because now I am totally lost on what we were doing before. Well, I know that we updated the starting dialog stuff, so now we have to fix a bunch of places. So where would this be? Starting dialog in it. Let's see, let me just see if I can focus a little bit. Yeah, you want, right, so you're just a key. You want this, which you say is this, and you say this is just a key. is, well, it shouldn't be. This should be like starting dialogue. Wait. No, we remove this. Yeah, this is actually just a key now because I made them the same basically. But we can keep, I guess we can keep, well, no. We'll remove this. There we go. There we go. Alright, let's go back. So you don't have this. Well, you're gonna be a key. Oops. Wait, where is the key? Dialogues. Dialogue option key. Alright. Wait, where is this called? Why do I not get references? Wait, do we even need this? Do we even need this? Is the thing. Because we already have this functionality basically in the option thing. Yeah, active. So we don't actually need this. I think we could just remove this because it's basically a copy of the other thing. It's basically this, but yeah. So I think I'll just remove this. Well, I will comment it out. And dialog state. Yeah, it's basically not gonna be... It's gonna be active, I think. Because that's... Yeah. That's how we have the options, yeah. So basically, I'm not gonna have this anymore. Wait, is this different? How much difference is there? What's the difference between this and... it's a diff of... Let's copy... let's do this. Okay, we're getting options from starting dialogue. And what about the options? What are they used for? We're just grabbing the options and we're never using them. Down here. Okay, I'm confused. Let's just assume that this is not needed. We can just use the generic one here. And yeah, draw active, fine. Right. Yeah, so I think this is also, we don't really need this. It's gonna be exactly the same as the other one. Okay. Alright, this is the one left here. We have a bunch of other places as well. But let's see, what are we doing here? This is when entering dialogue. Right, so we're starting, right, so this is where we start. This is the starting dialogue. So we don't really want to do that. We want to start at an active. now. So this is gonna be why. Okay, active. What is this? I mean, it's amazing how sometimes it like works, sometimes it doesn't work. Okay, so active is this. So we'll initialize it with an option, right? So it's gonna be .init. Okay. Target. Do we have the target? It's gonna be the entry key, I think. Okay, so the first is target. Then what? Option. So yeah, we need option and T. Okay, so what is the option? Option is going to be dialog container, which we don't have, so let's grab that as well. Get option by ID, and the ID is going to be starting dialog. Right. Or not. It's gonna be get starting dialog by NPC key. And the NPC key is well, we need to grab the NPC component, I think. And then you will have something. No? Wait, where the hell is... Where's the key? Wait. You will have the key, right? The key? No? Name component. Well, that's the dialog component. Do we actually not like save the key for... Okay, so we don't know which key it was. Well, I guess we could add it to the NPC AI component, I guess. Key. Yeah. Oh, that's key. Yeah. There we go. All right. So now we should... I mean, we don't have it, but we should... Key ID. There we go. Now it's there. So now we go back here, and now we can say, instead of... Yeah, so now we can say key. So now we can get the key. We get the current starting dialog option for this specific NPC, and now we can say that the dialog should be the active thing for this option here. Yes. There we go. All right. Okay. Now the thing we're also missing somewhat here is if we go to this function, we should, well, we need to we need to implement it, of course. We also need a way to change the state as well. So we do need to have a set as well. Set the thing, which will just be a key here, or we'll take a key, option key. Okay, and you will, well, actually you will return an option, I think. Yeah. All right, and here we will, well, actually this is a nullable, I think. So this will be wait, don't we need like self here? Oh, this is like compute. This is like comp time, right? But we want to get the state, so we need self. Yeah. And here we also need, this is going to be mutable. There we go. All right. Self. Starting states, get NPC key. There we go. Now this one, we do a get or put, I think. So entries, starting, get or put. We need an allocator. Yeah. NPC key. If entry. If entry. Come on. Is found existing, that's right. Found existing. Wait, oh right, because we need to catch. That's right. So if we found an existing, or if we didn't find, no, we always want to set the value to be option. All right, and now here this is actually wrong. We get the option key here, right? And then we can return get option by ID, option key. There we go. Oh yeah, it's nullable, so if we don't find it, we return null. Okay, dialog option, there's no init. Right, so this is init option. Alright, now we're fixing these. Nice. Here we go. Missing struct for storing data states. this. There we go. Or is it even, do we have dot empty? Yeah. So that is way better. Let's do this. Okay. Okay, no more errors in here. Okay, so the starting dialog that you provide is gonna be a dialog option key. So we'll remove this. You're also dialog option key. This doesn't exist. Fine. This is not a key. Oops. So what we'll do is we'll move this into the dialogues. We will say elder start and elder start 2. Those are those, and then Kottefolket start. So we need one for those as well. So now the starting dialog are defined in here now as well, which I think it does make sense. It's nice to have them all in the same place. So this is the starting dialog for elder start, and it's gonna be a dialog option init starting dialog with text, and on end it's gonna be change starting dialog to elder start 2, and the text is this. Right, and then we also need this text here, which is gonna be elder start 2. On end we don't do anything. So. Wait. There we go. And you, yeah, we'll do this. There we go. So here we have a starting dialog. Here we have another starting dialog. So they are a lot simpler than the options. Okay, cool. I mean, technically you could also have the options be a starting dialog, or, well, I guess that's what we had before, but yeah, they have so much in common that it makes sense to maybe have them in the same place. Alright, so action file dialog. Alright, this needs to be wrapped like this. Alright, and we're missing Kottefolket start. So let's go back here. And now this one is actually going to be elder start. Okay. Okay, and then Kottefolket start is this. And we'll remove you, and we'll move this into here. No. There we go. Right, so this could be an option. This could be like, if we don't get it from here, we actually want to get it from the component, so the initial value here, which is that. However, we still wanna get option by ID as well. There we go. And I don't get this error here because this is supposed to work. I think. Like, do I really have to type the whole thing out? I thought that I was not supposed to be able to have to do that. So this is like this option. Wait. No, it's not even. Oh, it's a response. No, what is it? What is this? Oh, it's a dialog state, which is in player. Oh, okay. So player components. So I really don't actually like this way of structuring things, that you have to like deeply nest into other stuff. This would be active. Yeah. Oops. There we go. Oh, that's the thing that needs what else. No. This is the thing that needs what else. Okay. What? Okay, maybe there's a syntax error somewhere here. Oh, let's see. Wait, it's like this. No. No, it's like this. Yeah, yeah, yeah. What? I don't understand here. Is something wrong in here? No. Oh, it's not a... it's like this. Oh yeah, okay, I already have it. Down space. There we go. Okay. Wait, are we done? No, that can't be it. Okay, there we go. Whoops. No thing named has state. Right, so. Alright, yeah, so now when we initialize what we do. Right, so dialog container has state. Alright, so if we contain that, we should be fine. However, I want to check also when we initialize this, like why do we need to supply which options an NPC could potentially have? We should just be able to like enable whatever option we have. I don't remember. I'm assuming that it's almost like we always assume that the thing is gonna be there, so it's like a maybe like a safety net that it's very strict on which ones it could be, I guess. That's not really a problem. It's just good to know, because if that's true, if it's true that we're sort of, let's say we show the option here, we get or put. Actually, we do get or put here, so that's not true at all. And we hide it as well. So are these? Oh yeah, because we are initially putting them in here, but if we already have them, then we don't do that. Okay, fine. So this should work, because at first we shouldn't have anything in the container, but then even if we transition scenes, we should have stuff in the container, I'm pretty sure, because this is a singleton. It exists between scenes. Okay, I'm gonna go for a little bit more here. We'll try and fix the last stuff here to get this back on track and fix the issue. Would be nice to have this fixed. Let's see. Alright, options. Then we have this here as well. So we want to so we're passing in basically all the options that it could ever have. So that should be fine actually, because that's just a flat. It just sets it there, and then the initially enabled is set here, and then we don't really need to save the state for anything else. Alright. Let's see what's happening in here. Okay, now we get some errors here. So what's happening here? Expected and opaque Oh, okay. Wait a minute. So this could be an issue here. Wait. Right, it needs to be a pointer. Which means that the iterator needs to be, it needs to be allocated and deallocated. Ooh. So we can't just put it on the stack because we can't just put it there because we don't know the size. But we could sort of generalize the process, though. So what would we need? Well, I guess we could supply a function here. We could say we could have like an init function which returns a generic iterator, and then we need an allocator for this. But wait, how do they do it with allocators then? Like if we go to keep, wait, anywhere it's being used? No. Okay, so it's not used here. The arena allocator has to be used, but that's not an, that's like a wrapper. So the context now, here we go. Oh, but it uses resize, which probably doesn't use, okay. So it never actually needs a pointer here. I guess you can do this, maybe. Yeah, you can. Maybe you can have like a container. Okay.
Wait, how? The self needs to be mutable, right? Wait, so first it creates the thing and then you basically get a wrapper. Because the thing is, we can't just create a copy in here and pass a pointer to that, because like that's that's on the stack. So like I don't have to like pass something else and then call a function on that. It just feels bad. I wanna just be able to pass the thing direct, or just return the thing directly here. But let's take this for example. We have debug allocator. This works. Right, so this one if you go to main, you create this like this, and then you grab the allocator out like this. I don't want to have to do that though. But I guess the state has to live somewhere. Unless you want to like, okay, another thing that you could do is pass an allocator in, so we actually allocate space for the iterator. But that seems unnecessary, especially when the value is basically just a sort of pointer to the thing, and we only have like one more thing. What would be the point of allocating that? It's like if we somehow could say like this is inline. Does this work? Like if you say it's inline and then we pass like this. No, but you don't need to.
okay, I guess we have to like make vtable. So iterator, so this is the state. Oops. And then the vtable is now state, and then this is gonna make an iterator instead. And this is the iterator, yes, and then you are the vtable. Why is this such a weird type? Oh wait, no, this, no, yeah, this is a vtable. Wait. Oh yeah, okay. This next equals vtable dot next. Reset equals vtable dot reset. There we go. Okay. Probably, yeah, we need to do the same thing here. But I have no idea if this works. I guess we'll find out. Wait, no, it's iterator. And then you are the thing to that. Oh yeah, then you are this. Okay, so now we get some issues here that is, I guess, related to how we're using this. So, because if we go back to where we use slice iterator here, no, not here, somewhere here, yeah. So this is where we have this sort of advanced, I guess, use case here. So we have an iterator that is iterating through this slice. So this will be an iterator where you get dialog option infos, which is the inner type there. And then we pass this into the map iterator, which is now like a higher order iterator. So it takes an iterator with type t, and then you have a map function that takes a t and turns it into a u, and then you get an iterator out from this function that works on or that you get u's out of. Okay, so but it doesn't seem to work properly for some reason. So do we get an error here? No. We only get an error in the map thing. Where it's like mixing and matching the types here a little bit. Oh wait, I'm stupid. This should be you. This should be you here. We're returning a thing that works on or returns you. So that was actually good. Expected stuff. Oh, yeah, and this should also be you. Yeah, there we go. Okay, we're interested to see if this actually works. Okay. Where else do we have an issue? Here. AutoHash does not allow slices as well as unions and structs to contain slices. Slices and structs containing slices. Okay. So that is the where's the dialog states and stuff. It's gonna be this one here. So it doesn't like this enum maybe or okay, let me get a better thing here. So where is this happening? Hash get starting dialog by an NPC key, dialogs 178. This is just a string. Somehow it's failing in here. Okay, but it is the new hash map. Or it does not allow slices as well as unions and structs containing slices here. Because the use of intent is unclear, consider using hash AutoHash strat or providing your own hash functions. I mean, it's just a string, right? Or is it yeah, it's telling me that I should use like string hash map instead? String array hash map. Or it's not telling me that, but and this is auto because this is an enum. Okay, so let's just use string array hash map instead. You only will need the option key there. Alright. Okay. So we got rid of all the compiler errors. Well, I don't feel super confident that this is gonna work, but we'll try. You do get a sort of thing when you fix all the compiler errors and say it does feel somewhat that now it's gonna work. Well, we'll see. You might get okay. So this works. Oh, but we don't get any options, and nothing happens after we talk to them. Okay, so that's good, sort of. Oh yeah, actually, I know why one of the things not happening, because choose response active dialog. So yeah, so if should show responses, accept button is pressed, advance, cancel. Okay, so let's check advance. Actually, if we don't have responses, that's the thing. If we don't have responses,
then it could be starting dialogue. We wanna check if we're done. Maybe we'll do it here. Actually, if we're done, if what do we have? Option. If we have on end, handle action. Target is target. Okay, so now we handle actions at least. I think if we actually had actions, we don't want the dialogue to end. Well, I guess this is gonna be a bit complicated. So because the previous thing went back to like show options after the starting dialogue was over, but now we don't have. Now starting dialogue is like a we don't differentiate. So I guess we could do like if wait, one of the actions is like show. Go to option. I guess we have composite, so we don't really need to have a. Okay. Actually, you know what? Let's not. Well, that's like the standard handler. Let's say. Let's have this be one thing only. Depends on itself. Oh no. But it's null though. Okay, I guess whatever, we can have several actions. Where did I go? Yeah, okay. How do I want to structure this? Okay, so basically, if this is true, that means that we're sort of done with the. Like this returns true or returns the list of responses if we're actually done with the conversation or the current sort of dialogue conversation, and then we also have responses to show. So that should be true in the case of. Yeah. We should change this. We should have thing here called like if is starting dialogue. It isn't active. Yeah, okay, well, I guess. And we'll just check if
let's say responses is null and on end is not null, then it's a starting. So this is basically a very stupid way of doing things, but this is what we have right now. And so we're checking here, should show responses, so that should be true if, let's say if we are a starting dialog and we are done, let's add like is done this. Self is last page and self is text animation done. So now we can say self is done. But if we are starting dialog and we are done, then we return. Well, it's not gonna be a response. Oh my god, it's gonna be different. It's gonna be options and not responses, man. Well, I guess we could make a list of responses. I guess it is a list of responses that will go to the option. Right. So let's actually do this. Let's do options as responses. This could be an iterator thing. Like if we get an iterator of options, we could get an iterator of responses, because now we have to basically allocate this. Let's return an iterator of responses then instead. Yeah, why not? Iterator of. Now this is kind of stupid. I mean, don't we have like response already somewhere? Okay. Components. Response. Okay, so we return an iterator of responses. And this won't work, but I'm gonna stick with it. So if we're starting dialog and we're done, we're gonna return options as responses. We're gonna pass in slice iterator of we don't have responses. Here. We have, where do we have it? Handle. Well, I guess we could do this. I guess we could pass in the options, which we should have as a it as a slice. It's on the dialog components. So should, yeah. So if we say here, for example, we have the active dialog. Right, so here it is. There's the options. Oh, there are keys. Right, fine. We can deal with that, maybe. Right, but then we need the infos. Man. Oh man, okay. Actually, you know what? Forget this. Forget this whole thing. Forget it. Hey, Two-Step. How's it going? Welcome. I'm gonna leave soon here, but I was just wanna get this working first. Are you using 0.14? Yes. So seems like you avoid redundant type names, a lot of place declaration literals. Yeah, I've actually. That's actually like. I have. So this is like a project that's been from 0.13 before. So I have a bunch of places where I don't do that. But there's actually. I don't think. I'm not sure if it's like a bug or anything. But let's see, do we have the active stuff somewhere? I think, yeah, for example, this one here, yeah. So if I say init, it's gonna be a compiler error, I think. No? Okay, now it's not a compiler. It was a compiler error before. Like it said something with enum literal cannot be a function or something like that. But yeah, maybe something else makes it so that we don't get it here. Okay, I will not do anything with this. I will say bool, actually. Okay, I'll just try and fix this and see. Wait. Oops, there we go. I don't know. Okay. Self. Right, self option. Responses. Okay. Right, so now we have to do. I'm just gonna show here once I get it like working here. Get responses. All right. Oh, responses. But I do know about it, and I'm trying to use it whenever I can. Oh, well now we don't get it. I thought it had something to do with like was it here maybe? No? Okay, now I don't get it. Okay, I don't know. But yeah, it was like some weird case where it was happening. Maybe it was over. Maybe it was something here. No. Okay, I don't know. Yeah, it is a really nice addition because I really enjoy not having to import every type to be able to like initialize things. Also, speaking of that. Okay, well, we're gonna have a problem now. So yeah, because the responses are basically for starting dialogues. We need to make the responses now. Oh, here's another one of these. Oh, we can actually. So I made this iterator thing. I'm just gonna do it here so we can see. So, okay. Here we have a function called drawList, which takes a list of strings as labels and draws it out and does a bunch of stuff. So, well, it draws. I think it only draws it. Anyway, the point is that you might not have a list of strings to give it like this, and in fact I don't, because I have I have these responses that are not a list of strings. So what I did was I allocate a new list, and then I go through and I set it to each, like I just copy the pointer here, and then I free this new list here. But what I did was I did this whole like iterator thing, so you don't have to allocate new things. So I made like a slice iterator that just takes a slice and it iterates through the slice itself. So this just takes a slice and you just increase this index here, and that's very like simple slice here. However, it also I did this generic iterator, which is kind of like the allocator in the standard library, which has a v table and you have this struct here with a pointer to the data of the state of the iterator, and then v table which describes the functionality, and then these generic next and reset functions that call v table. So it's basically like the allocator, except you pass in a type as well for that. So then you can so now I get like a generic iterator here. Well, then you can use map iterator, which takes an iterator, a generic iterator, and a function that maps from type T to type U, and then you get what you get out is the generic iterator of type U. So this one, it basically takes in these things and it just wraps this iterator here. The data is just saves the iterator. Next, it just calls next on the next iterator, or the wrapped one, and tries to know if it doesn't exist, and it calls the function here, and then reset, it just resets there, and then we just return this thing here. So now we have an iterator. Yeah, that's the thing, with pointers to the local. So I'm very wary about this. I added inline here and just hope that it works. So I just wish there was a way to have this more easily done, you know. I mean, that's the problem here. This is the only problem with this approach, because the other thing you could do is you could create sort of like GPA works, where you create a struct in the local scope and then you call function on that, where that is like a mutable, like GPA is mutable, and you call like this. So you create GPA first, and then this is also kind of strange where it's like .init is not like .empty or whatever. But anyway, and then you call allocator on the mutable version to get the actual allocator out. I don't like this pattern. I want to just call the function to get the thing. I don't want to have to do this crap. Pass in a pointer iterator. Where do you mean? You mean when you okay, yeah, but that's the same. That is what I showed here. So basically, you create. So GPA works like that, but now it's called debug allocator. So you basically create this other struct first, and then you call allocator to get the like generic allocator out, and then you have they put the pointer here, which is like this pointer here, but I don't want to have to do that. It's like, yeah, it's messy. It's yeah, and you can't even do things like this, where you try to get, let's say I want the allocator and I want to just call this allocator. This doesn't work because, well, it's a reallocation, but this doesn't work because now it says that this is a constant, or it's like non-mutable thing. So you have to like store it first, and then yeah. So see here, it expects a mutable here, but then it found a const. So this would be nice though. This could work, but it's just I don't like this pattern here. Well, at least you don't have to allocate anything, I guess. It's also like each of these things is gonna create its own struct that you have to call init on. I mean, maybe you can do this. Maybe you can say, okay, function init self but now it no, we have to do it. We have to yeah, I don't know. I'm just gonna try this and hope that it works. Because I read that inline is like it's not really dependable to do what you think it should do. There's something about like result location resolution or whatever it's called. Yeah, returning pointer to local depending on inline will literally break if the optimizers. Yeah, that's true. Well, it did work now, but it's like, do I want to mess with that? The other thing is that the pointer, it's like the pointer is anopaque. That's if it could be more generic. I mean, it is very generic, but if it could be not a pointer, that would solve it. But that's not possible because you're trying to. I mean, I guess. Well. It's like if a function is gonna accept this type, it's gonna have to know the size and stuff. Okay. But yeah, I think okay, so let's try this. We will make, let's do like map iterator. Okay, let's do function comp time t. We will return a type, and we're gonna return a struct that is gonna have a function called init, and this one is gonna do this, and this we're gonna have self, or let's just do it, maybe it for iterator, you know, and self is this, then yeah, we'll return, well, okay, yeah, and now we can also store the state in here, I guess. And then we say this is gonna be, well, yeah, it's gonna be this. And the v table, we can have that as well. Let's copy this. I guess we need you as well. Okay, I'm basically copying the entire thing here. Okay. Oh yeah, and the mapper. Oh yeah, we need mapper. But this is basic. Okay, let's just put this in here. Okay. And then, well, what I was trying to do was to make a more generic version, perhaps, that you could use in so you don't have to like copy this every time, because it's gonna look the same almost. And then we don't create an iterator like this. We just return the iterator as the type. Right. Alright, so we don't have to refer to this. That's right. So we just do this. But now it is a type function, so we can do this. Okay. Okay, and now if we go back, well, now we have to do the same thing for the other one, but let's go back here, and now this is a map iterator, and then you have to call it on it to get the actual iterator. It doesn't, the LSP doesn't understand anything. Oh yeah, because now we have to first call map iterator, like we have to first do this, like iterator, map iterator. This is this type, and this is the string. We need the slice iterator as well. And then, but now we can call this, and here we can call, well, here we supply this function here. Okay, so that this is our type, yeah. Actually, wait, have I done this wrong? No, it shouldn't be a type. No, it should be this type. Wait. Yeah. Iterator. But we don't have that type yet, so let's do. Yeah, so now we need to do this. Alright, there we go. But then we don't have access to the V table. What's happening here? Is this possible? Well, I guess we could do this for the V table. Maybe we could put this in its own function. V table, and then this will be a type. And we need T, we need U. We need the mapper. Okay. Wait, but okay, I see the problem here. This depends on the vtable and this depends on the iterator. Like, why can't the vtable just be a type? Why does it have to be this weird sort of like value here? Next, I mean, I guess it's just like these are com time, but why do I have to create this struct? Why can't I? Well, I guess because it's a type, maybe I can't. Like, why can't I just do this and set this to a type that it asserts that we have the functions on, and so this will be like, this is a type, and so yeah, we don't care about you. Why is this? Is this not possible? So then this could be, but that doesn't really help me, I guess. Or does it? Okay, and then vtable. Okay, will this be like a infinite loop here? No, that's not. So we need to populate it. There we go. Wait, mapper needs to be com time, right? Duplicate struct. Why does it say this? I don't understand. Oh, I see. So this would be like inner. There we go. Okay, let's just remove all this. I mean, I guess we could just move this in here instead. And now this a type, or is it a type? Wait. No, the whole point was to be able to refer to the type from outside. That's right. Okay. Okay, so yeah. There we go. So you call this function. Well, it doesn't need to be inline anymore, I guess. And you get this out. So we get this value out, and then you have to like store it as a var thing. It's not a type though. Oh. I feel like the LSP does some weird assertions if the name is like this isn't. I mean, well, I guess this wasn't public, so. But anyway, now we have. Whoops! Now we have this guy, and so okay, great, and then the iterator. Will be map iterator.it. So now we actually get the iterator out safely. However, we also need to wrap the slice iterator. So we also need a slice iterator. So we need to do the same thing here for this slice. It's gonna be the. But now we send in responses. And the types are wrong as well. Also, it would be cool if we could like automatically determine the types based on the things you send in instead. But I know that that's very unziggy sometimes. I've got the feeling. But it's weird because it's both Ziggy and unziggy, I guess. Zilla's comp time engine is pretty weak. Fingers crossed the compiler server happens soon. Yeah, that would be really nice. The LSP is like very hit and miss. Map iterator could return. Yeah. Wait. You are correct. And that isn't even 0.14. Okay, I'm just scanning for other places. Okay. So, slice. Let's do, I guess, we'll do the same thing here. So we make a slice. We return this. And then this is the key table. Wait, this is so now, okay, so now this is where this part I want to like generalize, because it's gonna be the same for everything. But yeah. If we say vtable this, except this isn't exactly the same, but what's happening here? Yeah, so we don't do this. We say slice iterator slice, and we return value equals slice. There we go. Right, so now we are, well, okay, wait, this is not comp time. Oh, okay. So we actually need to pass in my type here instead. And there we go. T. Yes. And T. Okay. So great. Right, so we have this. Wait, what? Map iterator. TU iterator. What do you mean? Do I have to do this? No, that doesn't make sense. Unable to resolve comp time value. Now, but wait, this iterator, it's supposed to be just something we copy in here and that we can use. That was inner. Oh my god. Okay. We're trying to assign a function there. Wait, is that even possible? No, this is a public, this is a declaration. Okay, anyway. Now yeah, I'm pretty sure we can do this. Like iterator, it. Although it's a little bit messy here. Okay. Struct. Yeah, so this is unused. This is how it looked before. You had to do this, but it's like we don't know if it works or not. And it's also a little bit messy. It would be nice if, like, what the things that would make this prettier would be type inference, so you don't have to specify the types. More easily create functions on the fly. I think both of those things Zig doesn't really want to have, so yeah. Maybe this is a bad pattern for Zig. But it's fun to try it out. Alright, now we can call this variation instead, and we pass in the iterator there. I hope we don't get any weird errors and stuff. Okay, so we do get some crazy things here. Oh yeah, this is the other place. What, I get this again? Wait, this should be just self. Oh, maybe it's this one. Maybe this is the weird thing. Right. Okay, so maybe we actually need to have this weird structure here. So are these actually pointers? I guess they are pointers to the functions that you assign. But I don't understand why this needs to be like a pointer to a const. I guess so it doesn't change. I don't know. We still get this error, or okay, expected type. Oh yeah, so now we actually get the error here because of this type is wrong. So it's gonna be now component option response. All right, and it's the same for you. And it's never mutated, but we do send it in here. That's right, that needs to be that. Okay, there we go. Now things happened. Needs to be a const pointer, so it's statically known. Oh, okay. Right. Because otherwise you could point to whatever, or, well, I don't know. I thought the point was you could set it without putting it in the type. Well, I don't know, man. It feels like you should be able to just set it as a type that should also be statically known. I don't know. Okay, it's not that much more inconvenient, I guess, but it's a bit inconvenient. Maybe you could wrap this somehow, but then you still need to create a state for this every iterator along the way. So it's not really feasible to keep, I guess, stacking these, because you can't put them into a function and easily call it, because you need to have the thing on the stack. So unless you allocate, I guess, space for it, maybe. But then you don't know how much space you need, I guess, for the whole thing. Okay, but anyway, let's copy this and we'll put it at the other place. But now we need to change the type, and we need to change the function. There we go. And this also is options. Okay, but now we don't have to allocate a new list of strings. Huh? Isn't that great? Okay. Are we done? No. Oh man. What? How can it be this bad? Is there like an infinite loop somewhere? No, it would detect that, right? Yeah, it seems like it has like an infinite loop or something. Oh, is it because they depend on each other? Man, so it's not possible. Is that really true? No, but couldn't we just put the V table in there? Like, why do we need it outside? We don't really need it outside, right? We just need to, we just put it in here. Right? And we don't need it to be a function. Right? And then you, actually we could do this. We could say iterator is this. There we go. No, but that's not correct. Wait, is this function? Or this thing? That's the iterator. There we go. Right? Wait, did I delete a bunch of stuff? Right, so we don't need a mapper for this, I guess. Well, where's the mapper though? Where you, well, within the mapper, why does it say unused? Function. Oh yeah, then we return iterator, that's right. What's happening here? Undeclared identifier. What? Business practice. Okay, so I don't really understand. This says unused, it's not unused, and this is undeclared. Well, I guess it's undeclared in this. we do this. But how can... Now that is undeclared. I mean, I think you should be able to. I guess we could put this undefined. The only thing now is like this is. Well, actually no. Why did I think that? We can just do this, right? We don't have to type called vtable. We just need to do this. Okay, now we get some weird errors here, but that doesn't necessarily have to mean yeah, this is you, and the inner is T. That's right. There we go. All right. Okay, let's do the same for slice. Well, I'll just see if I can remember here. So we'll put these in here. I guess they don't have to be public. Maybe. Then iterator is this. Then what else? Yeah, we just return you, and you are gone. What was this? Let's make this non-public, I think. Alright. You say something here. Oh yeah, so now we need to do iterator. Okay, I think we made maybe progress. We'll see. This is response. Okay. Oh wow. Okay, it says no more errors. Yeah, okay, so I mean it looks like it actually works. However, there's some bug now where Where? Okay. Wait. Well, this doesn't feel good actually. Because it crashes in the middle of the like what is it? The sentence, so it feels like it's accessing memory that it shouldn't. Could you move the vtable functions into? Oh yeah, that was what you read before. So it does. Well, I don't know why it doesn't work, but. But this is nothing to do with iterators, I don't think. This is like the active dialogue. And we're drawing the text. It's this part here, I think that's the issue. Okay. Well, actually, I thought it was longer than that. It's probably crashing right as it tries to render the last thing. Yeah, it's crashing on the last character. So, okay, let's just look at the crash thing. Null value. Oh, so okay, that's good. Yeah, we're in the process of redoing this a little bit. I had like a distinction on starting dialogue and like the dialogue that you get when you first talk to someone, or when you first like open up the dialogue. We had like I had like starting dialogue, and that was handled like differently, but now I sort of merged those two together, so it's like now it's only one thing called active dialogue, and so that's why it's crashing now, because I'm in the middle of like merging these systems here. Let's see, so it's well, yeah, it's handle active. Oh, it's here actually. Yes, and then in here and right. So here. So if we should show responses, so this is basically. I'm just gonna do it very badly here. If this is a starting dialogue, we will actually get the responses. Let's do this. We will make. Wait, will this create a scope like a stack? Okay. Do I? No. Okay, I just realized something. You could do this, but it's a bit messy with the iterators if you want to like compose them without doing stuff. Without having so much things in there. Let's say this one for example. So let's say we put this in a function here called like responses iterator. Now this would return a generic iterator of dialog component option response. Right. So wait, couldn't we now just no, because these are now yeah, the problem is here, like here it decides that this local copy should be the pointer that is stored. Yeah, that's the whole problem here. So this doesn't work. What I was thinking, like maybe we could like wrap them in a struct and then return the struct, but that's the same issue. Like you return a struct, you copy by value, and the pointer is wrong. Okay, never mind. What I was thinking here is maybe I could like make an iterator of responses, but it's gonna be super messy here. I really don't like this pattern actually, because every time you need to use the iterators, you need to copy a block of code in here. It's nice when if you could make if just that little detail, you know, but it doesn't work. Like if it could be inline, if you could be sure that it's been inline. Okay. Yeah, so the whole thing here is like if we are starting dialogue, let's just make functions here. Handle starting dialogue responses, or wait, handle yeah responses otherwise handle active dialogue responses. No. Okay. Right, so here well, the thing is here now we have option. Well, we don't need option actually. We need what do we need? We need the dialog container. We need option info. Oh man, okay. Keys. Okay, we could. Oh man, no. Okay, I just came up with a stupid idea, but maybe it is actually feasible. I think the thing that you said before, like if you could pass in a mutable thing. What if you pass in a mutable container for a list of... No, that's stupid. I was thinking like you could pass in a list, a container for like a list of places where it could like if you pass in an iterator. Well, not an iterator, but you pass in a place where the iterator can store its state, basically. Maybe you just need an allocator that is like in memory. Or yeah, but I mean, that has like a buffer or something. I just put the state in there. I don't know. Okay, now it's becoming way more complicated here than it needs to be. Just to get this, just to avoid doing an allocation with a new list and then looping through some stuff to set the new list to some other value. But yeah, so we need the option keys. Now where are those? Well, those are gonna be, oops, dialog component here. That's, and then they are component is options. There we go. Okay, now we have those. We have to also free these things, and we have to get the allocator. Zig is just as bad at functional programming stuff like composing iterators. I don't know if they will ever try to improve it. I don't think so. From what I've read, they don't want better support for that kind of stuff. As I said, the where is it? Here, like type inference would get rid of these, so you don't have to put these. And then if you could somehow make this better, like, you know, response label like this, they will not support this. From what I understand, this is not the direction, from what I've read, that they will go. But you never know, you know. And probably is a bad idea to try to do stuff like that. But it's fun to try it, at least. And I mean, it does work. It's just it's a bit cumbersome to use. And it does actually functionally do something as well. It's not like it's just, you know, programming. Yeah, whatever. It actually solves a problem that you don't have to allocate a new list and loop through it. You can just create this iterator that has a little bit of local state to iterate through something that doesn't exactly has to have the thing that you need to do. I mean, I guess another way could be to, well, it's not that Zig doesn't like iterators. Like, it does have a lot of iterators, but it's like every iterator is super specialized to the thing that you need to do. And you can still do that here. And I guess that's kind of what the consensus is, or what you need to do. Like, okay, so I need to make myself an iterator. So this will be the process instead. Instead of composing iterators like we do here, we have to like say, okay, now we don't even need this. We can just say index, and then we make a next function. And so you do this every time, like yeah, what we need is this. So, oops. So then we return. Wait, we need self. So then we return responses, index, label, and we need a reset function. So that would be the process by which I think they want you to do. Like you write your own iterator right there, if you need a special case here, a special kind of thing, and that could be cool. I mean, it didn't take long, but you know, I don't know. It's like, what's the there's no difference really between this and that, but this is like more generic, and you can compose and you can do all kinds of stuff with this. But it's like super, yeah. And then you just create, you just do iterator equals iterator, and so that's kind of does the same thing, yeah. Yeah, but anyway. Yeah, it is useful to avoid allocation, so that it actually does something. But what I'm saying here, like, maybe this is the sig pattern instead, like creating this like this, instead of creating this super composable thing. Async might be useful for this stuff too, hopefully soon. Yeah, I have not looked into that anything actually. I never played with Zig once they had it, so I'm not sure exactly how it will work, but I mean, I'm probably gonna change it as well, maybe. I don't know. Wait, where's the things? Yeah, so here now we say, so now we get some option infos, right? So now we can loop through them and create an iterator that's gonna loop through them and create responses, or we do allocator allocate I mean, I guess if you had a better allocator, this wouldn't be that big of a deal, I guess. You could have like an allocator that, I don't know, that had some capacity and stuff, so it wouldn't be like you allocator, like a specialized allocator for these kinds of allocations where it's gonna happen every frame and it's gonna be a small amount of items, and so you don't have to do a syscall and stuff, if that's what's happening here. I'm not sure actually, but okay, yeah, I have to go here soon, but let's see, and then we have to loop through these. This is vänta. I just got scared there. Option info, option label, or else this. Okay. Right, so now we have responses. What's this? Oh, we don't actually need labels, we just need responses. God damn it. What do you have? Label and action. Oh yeah. So the do this last thing. I'm getting bombarded here. So let's do. Actually, this should be a list of responses. There we go. Well, actually, yeah, okay, we can do this. Okay. Wait, a list of response. No. There we go. Okay, label and action is go to option. Is it a key? I think so. Wait, where's the key? Oh, it's option, keys, options. No, it's... There we go. Yeah, we're mixing and matching a little bit with the functionality. Or with the types of programming that we're using here. Expected type, diagram option. What? Wait. These are keys. Oh, you want an actual option. Okay. So, okay, so then it's like option info and then option. Okay, there we go. Okay, but it's like we need to do this every frame. I guess it's fine. Whatever. What's this now? Dialog options. It's not a function. What? Dialogue option info is not a function. Oh, what happened here? Wait, what happened here? There's no changes here. So how did I never call this function? Maybe I never called this, I think. Wait, so let's see what the hell is happening here. We're creating an array, a new array, right? We are populating it. There we go. Okay. Oh, still crashes. Okay, I'll see if I can fix this real quick here, and then I have to go. Yeah, it's the same thing. Draw responses. Okay, yeah. Draw active dialogue. So it's like, I mean, let's have the same thing here and say, well, actually, it might be not that big of a difference. Draw responses. So actually, if Okay, so yeah, thank you very much. It was fun talking about this. Thanks for watching. Duplicate. Wait, where is it? Oh, okay, and then right. So here we want the whole thing. Where is it? Handle. All this. Wait. All this. And we don't free it. There we go. All right. I mean registry, allocator, and active app. Right, so now go back to here and we replace all of this with get responses. And we don't need to do this. Yeah, a little bit more terse than creating iterators and stuff, but now we have to do allocation. So, but anyway, all right, let's try it again. So this is gonna be the last test here, and I have to go. There we go. It works. However, oh yeah. So we still have one thing left, and it's like and the next time you talk to this guy, he's gonna say something else, and that's not happening. So that's like I have to add it. But that's the easy part. Now it actually works. Let's see if we can. Oh, but now this one is available. All right, maybe I'm looking at the wrong thing. Yeah, I should be looking at the available. Actually, let's just do that pretty quick. It's gonna be is like pretty quick here. It's gonna be so. We need the container show get shown infos. That's right. So, and the keys. There we go. This is the option infos. Okay, there we go. Alright, so talk to this guy. Here we go. Do you want some gems? I need 5 gems. Okay, sure. Now we talk to this guy. Okay, we only see who are you. So this was the bug that we were gonna fix from like before. So if we enter and exit now, it's gonna keep the state. Yeah. So now we only see this. So if we go and complete the quest now, should do pretty quickly. Man, they have like too much HP. I need to. They should only have like 2 or something. There we go. So now the quest is progressed. Wait, does the thing disappear when I change? Okay, and now we have this. So there's my reward. There we go. Awesome. Okay. So great. So what's left on the thing there is, well, I'm not gonna, so I'll add a to do here somewhere. Where would it be? I'll just add a to do here. To do run on end action when starting dialogue, or when dialogue is done. Okay. But that's gonna be it for this time. So thanks very much for watching and tuning in and chatting and stuff. Hope you have a nice day, and I'll see you later. Bye bye.